books is in. The books are in. Yep. They in. They're here. ETM Hotel, Rennie Shawn. Welcome in peace. My name is Shawn. I'd like to thank everybody for tuning in to Science with Shawn. I just want to go over the latest news and give y'all an update on the vaccine trial that was in play. Not necessarily in America, but just in play. So just give me just a second, you know what I mean? Like the show, share the show, tell a friend. What's good? What's going on? And we're going to build. I may break away in just another second. I'm trying to give myself another couple of seconds here so I don't interrupt the bill. But hopefully everybody's doing well today. You know, we approaching that 10 million mark as far as people vaccinated. So we doing our own trials right now. You know, with the people who have already been eligible to receive the vaccine, we can do our own trials right now. You know, we're waiting on more data. We want to see the adverse effects of the 10 million people who've received the vaccine. We want to know how things are going. We want to know if they've had any allergic reactions. So far, we had 29 allergic reactions out of 10 million people vaccinated. Could be 31 or 32 by now. But it looks like the numbers are really well. So the chances of you receiving some type of allergic reaction to a vaccine are slim to none. Appreciate that, Daryl. Daryl says get Dr. Inky or Marvin on here for some knowledgeable, some knowledgeable people. Daryl Holly's the dude that told us to go and eat the what kind of soup you say eat, Daryl? The hot pepper goat soup that cure COVID. Ain't that what you said on another panel? funny guy. Go get please, brother. Inky's no doctor and Marvin is no scientist. Neither one of them discern information, and they are not credible. If you really want me to go in there and go in on the second brother that you actually named, I could actually do that. But this is not the show for that. So I want to just keep everybody posted on what's actually taking place and what's going on in the scientific community. I don't want to bog down, bore, or dismay anyone. I see people coming in the building, man. So let me go ahead and say salute to Charles Vassar Akuma, which I won't say your name, Akuma. Peace to you, sister. Teti, what's good, brother? You know what I'm saying? What's going on in the world? I don't know who else is watching right now. It's kind of out of the blue bill. You know what I'm saying? Hopefully people are receiving the notifications. If not, you know, YouTube, of course, is tripping. Please like the show and share the show. Give me 1 second here, then we're going to get started. What we need to get started with. All right, what up? Too Smooth. What's up, Pure? Sci-fi, peace to you, sister. Amanetta and Zinga, peace to you. All right, Mboka. Jama Mboka. All right. Hope everybody having a good day. Let's get started, man. Let's go ahead. I'm gonna share my screen. People join in, they join. If not, they don't. It's all good. I just want to talk about something real quick. So a man dies after judge forces clinic to use unproven COVID treatment. Man dies after judge forces clinic to use unproven COVID treatment. Now, why would I actually show this, right? Why would I show this? Because there's a lot of unproven COVID treatments that we are hearing in the community. Ivermectin being one, hydroxychloroquine being another one. You know what I'm saying? They're talking about some herbs and some spices and some home remedies such as steam from a pot or some type of liquid syrup or courage that you can conjure together to actually mix up to present it to the people, right? But you know, when things like this take place, you have quackery that rest assured. You see this quackery, a history of fake medicine and cure. You know, I'm not gonna hit play on that because I ain't got time to hit play on that. But there's a history of quackery and fake medicine. Now, Buenos Aires, an Argentinian judge compelled a private clinic to administer chlorine dioxide used as a powerful disinfectant to a coronavirus patient who died Monday in a case medical doctors had labeled a scandal. The US FDA and other agencies warned that chlorine dioxide, touted as a miracle cure online, can be hazardous to human health if consumed. In a wake of President Trump suggesting that disinfectants might be injected to treat COVID-19, a number of Americans were hospitalized for ingesting cleaning agents, and at least 3 people were charged with criminal offense for selling chlorine-based products as remedies for the disease. The stepson of the patient brought a legal bid last Thursday, the day after his mother died of COVID-19, for a compound to be given to her critically ill husband. A judge granted the request the same day and ordered the Antomadillo Morolo Clinic in Buenos Aires to administer the substance prescribed by the patient's doctor. Now, the clinic unsuccessfully appealed against the ruling and gave the man the substance while stressing it would not bear responsibility for any negative outcome. The patient, a 92-year-old man who was in critical condition from the virus, died Monday, the family's lawyer confirmed. Here you go, showing there's a man right there showing you the bottles of the actual chlorine dioxide that he purchased. All right. The FDA has warned that consumption of chlorine dioxide products can jeopardize a person's health, have no proven effectiveness against COVID-19, and have been known to cause respiratory and liver failure, among other ill effects. The Pan-African Health Organization, the Argentina Society of Infectology, and the country's National Administration of Drug, Food, and Medical Devices have also issued warning against the use of chlorine products to treat COVID-19. The judge ruled that giving the treatment threatened no serious harm to the clinic, but could conversely avoid the worsening of the patient's conditions. Medical doctors have lambasted the decision. All right, here we go. Judicial aberration and a scandal. For a judge to decide that a doctor has to administer a substance for which there is no scientific evidence is really worrying, especially when it is a treatise form, said Omar Soud, president of the Argentina Society of Infectology. It is not the decision of a judge to administer a medication he does not know to a patient. It is not his role. Maglio, the lawyer for the Argentinian health NGO, Fundación Hesped, said the case amounted to judicial overreach, a judicial aberration and scandal. So chlorine dioxide is used to disinfect medical and laboratory equipment to treat water at low concentrations or as bleach. The family's lawyer told the television channel C5N that his client will sue the clinic as they consider it responsible for the patient's death because it delayed treatment. The man died in a hospital infection, and because of the delay in treatment, the lawyer said. Argentina announced Monday it would roll out a new COVID-19 therapy developed by scientists locally using serum extracted from horses that develop antibodies after being injected with coronavirus protein. They're a little late to the game on the injection of the protein and so on and so forth. But I'm not going to get into the whole, the rest of this particular article. Look, it was first published January 12, 2021 at 8:41 a.m. So this is recent, but they have already been testing for antibodies in horses because horses seem to be able to fight off the coronavirus. That was last year's news. This is something that we already knew about the horses, that they were trying to study to see what was going on in the horses to derive for the outcome. We can go back to the testing in animals to actually prove another point of the reason why they ain't start using the stuff that they got from horses on people to see if they'll develop some type of immune response to this actual virus. So again, peace, brother Chavis, Keisha, Indonesia, also Kisu, peace. Thank you for joining. But roughly what I was dealing with is that these miracle drug people, and this is something people in the conscious community, began to tout. Man dies after judge forces clinic to use unproven COVID-19 treatments. It's just wrong. But there's a history of fake medicine and cure. Let's see what it says. I won't go play it, but I'm gonna give it to you. Let me mute them out just for a second. Don't want to play any ad. The video. Okay, now I can skip. Let's get to it.
Experts are on TV seemingly around the clock offering all kinds of advice. And then Morocco reminds us there are the quacks.
Not only did I create the cure,
a self-described genius entrepreneur with a coronavirus prevention pill arrested by the FBI.
Because you take this pill once a day, you cannot contract the virus.
You're saying that silver solution would be effective.
Televangelist Jim Baker sued by the state of Missouri to stop promoting Silver Solution, a so-called cure for COVID-19.
Totally eliminate it, kills it, and deactivates it.
Yeah.
They're just two examples of what's considered modern-day medical quackery.
Quack actually originates from the word quacksalver, which is a Middle Dutch word that means somebody who boasts or brags about their self. So it's someone on the street corner who's hawking their wares.
Dr. Lydia Kang is the co-author of a book on the long history of quackery, which she defines as the promotion of a treatment or cure without a solid scientific basis. In other words, fake medicine. And it's generally thought to have reached its heyday in this country toward the end of the 19th century. When I hear the word quack, I instantly think snake oil salesman. Why?
So way back when, it was the end of the 1800s, there was a guy named Clark Stanley who was selling a liniment that he claimed had snake oil in it. And he was saying it was basically could cure everything.
As for what was actually in it,
it had beef fat and pepper and turpentine, but there was no snake oil in it. And he made a ton of money off of it.
But many discredited practices were genuinely considered best practices in their time. For thousands of years, tree panning, the drilling of holes in the head, was used to release evil spirits. And long before the current opioid epidemic, opium, the highly addictive narcotic derived from the opium poppy plant, was a respectable go-to pain reliever.
They used it for everything under the sun. So, if you're having a bad day, you would take some opium. You're nervous, you take some opium. If you have some crying babies at home and you're busy parents trying to go to the factory, you dose them up with some opium.
Heroin, a derivative of opium, was once even sold over the counter by Bayer for sore throats and respiratory ailments. At the opposite end of things, there were equally unscientific remedies.
My gosh, they use so many different things in enemas. Pretty much anything in your kitchen cupboard could go into an enema. So things like milk and honey.
Tell me about the tobacco enema.
You've probably heard of the term blowing smoke up someone's.
Yes, that's where that expression comes from.
In England, for a little while, they were actually used as a means of reviving drowning victims.
And remember mummy eating? You're glad you don't.
One of the weirdest things is that Egyptian mummies were taken from their tombs, stolen, and sold overseas because they were considered this fantastic remedy for everything.
How could you be assured that you were eating a ground-up mummy and not just some random guy?
That is true. And so people would sometimes take like dirt and soil and ashes, and they'd be like, oh, this is bona fide real mummy.
Now, lest we mock our benighted forebears too much, are there any accepted practices today that might very well be seen as quackery in 50 or 75 years?
Oh, absolutely. It's funny. When I was in medical school, there was this saying, which was half of what we're teaching you here is wrong. We just don't know which half. 50 years from now, the things that I think are going to be really considered right now kind of barbaric are going to be things like the way that we screen for cancers. So, for example, doing a colonoscopy and having to drink that terrible prep and going to get the actual colonoscopy done.
Of course, colonoscopies work. They're essential in screening for colon cancer, an important distinction from certain products being pushed today.
And so there's lots of public concern about COVID-19. And so scammers everywhere are including that in whatever they're marketing.
Dr. Stephen Barrett runs the internet site QuackWatch.
The most dangerous is so-called Miracle Mineral Solution, MMS.
Miracle Mineral Solution is an industrial strength bleach. That's right, bleach, that has been falsely promoted as a cure for everything from HIV to malaria and now COVID-19.
The FDA pretty much drove the sellers out of the U.S. market.
And then I said, supposing you brought the light inside the bottle.
Yet this past Thursday, President Trump wondered out loud whether injecting household disinfectant into the body might kill coronavirus.
Right, and then I see the disinfectant where it knocks it out in a minute, 1 minute. And is there a way we can do something like that by injection inside?
Medical experts and manufacturers were quick to point out that consuming those products can kill you. In recent weeks, accusations of quackery have been leveled against two of television's most famous doctors. Heart surgeon Dr. Mehmet Oz was criticized after hyping the use of the drug hydroxychloroquine as a treatment for COVID-19 when the benefits are far from conclusive.
Well, that's where hydroxychloroquine plays a role. We've been talking about it a lot. That's the malaria drug.
He has since reversed himself. Dr. Phil McGraw, a former clinical psychologist, incorrectly compared the disease's danger with other causes of death.
45,000 people a year die from automobile accidents, 480,000 from cigarettes, 360,000 a year from swimming pools, but we don't shut the country down for that.
He too backtracked. While the peddlers of quack medicine may have mixed motives, Dr. Lydia Kang says the patients should always be treated with compassion.
And a lot of it really just comes down to fear. People don't want to be sick. They're afraid of being sick. They don't want to get worse. And hope. They want to get better, and they'll look for whatever they can to do so.
For more, join Mo for a live.
So there you have it. Inky is on QuackWatch. Let's get that out of here. Anybody got any questions, comments, or anything, concerns about what I just showed you? Anybody? So let's get into it. We got that on out of the way. All right, so y'all remember me mentioning Sinovac or talking about it maybe on Facebook, anything like that. It's this new wonder drug for COVID-19. All right. Brazil announces fantastic results for Chinese-made COVID-19 vaccine, but details remain murky. This was published, look at the date, 1/7/21. Follow me. I'm not going to read the whole article. As you know, if you're following me, everything will be in the description. Brazil, with more COVID-19 cases than any other country after the United States and India, is on the verge of having its first authorized vaccine for the pandemic disease. At a press conference today, Brazil researchers reported that a vaccine made by a Chinese company, Sinovac, was safe and had 78% efficacy in preventing mild cases of COVID-19 in the study of more than 12,000 healthcare workers. It also completely prevented moderate and severe illness caused by SARS-CoV-2 infections, the team said. The results we are seeing today is fantastic, Rosanna Rickman said. She's a physician from the Emilio Ribas Institute of Infectious Disease. All right, now, that's how it leads. Okay, It continues and says, Dimas Tadukovas, head of the Buchanan Institute, a state-owned vaccine maker that is co-sponsoring the trial, experts Brazil regulatory agencies to authorize the vaccine called CoronaVac for emergency use in the coming days. We have now all the documentation to make the request, he says. Brazil also has efficacy trials underway of COVID-19 vaccine made by AstraZeneca and the University of Oxford, and many scientists there are expected to receive authorization soon. But the good news about CoronaVac was overshadowed by complaints that the announcement included little data and that Sinovac has muzzled its Brazilian collaborators. Indeed, Brazilian researchers had previously held a press conference to announce the vaccine was a success, but were not allowed to give an exact efficacy figure at the time. Said most of the vaccine authorized in other countries rely on high-tech approaches such as messenger RNA coding for surface proteins of SARS-CoV-2 or harmless viral vector carrying the gene for the protein, the approach taken by AstraZeneca Oxford vaccine. But Sinovac turned to a more established approach. Its vaccine, which is also in efficacy trials in Turkey and Indonesia, relies on the whole coronavirus chemically crippled, so it can't cause disease. So Sinovac is a conventional vaccine, and it still was made in less than 5 years, the conventional way. And it's in trials in Turkey and Indonesia. But peep this. They're going to inject you with the virus, with this Sinovac. All right? The dead virus. So don't get scared. The reported efficacy against mild disease falls short of the roughly 95% achieved by 2 mRNA vaccines. But the main purpose of COVID-19 vaccines, COVA says, is to prevent infected people from progressing to severe disease. There you go. They're trying to prevent you from progressing to severe. A different whole inactivated SARS-CoV-2 vaccine made by Sinopharm's China National Biotech Group has nearly identical results. The company reported last week from a large efficacy trial in severe Middle Eastern countries. Now, both Sinovac and Sinopharm have kept a tight lid on what their partners can reveal about their vaccines. At the December 23rd press conference held at the governor's residence in Sao Paulo, researchers said that because of the contractual agreement with Sinovac, they could only report CoronaVac had greater than 50% efficacy, an internationally accepted standard for emergency authorization. Today's presentation revealed the specific efficacy rate, but researchers were coy about describing the exact number of people who developed disease in the vaccinated and placebo arms. It gets better. In a formal presentation of data at the Buchanan today, Covas made no mention of the case number, saying that the data will be reported in a scientific publication and the Brazilian regulators. But when pressed by journalists, he allowed that there were 218 cases of mild disease. The exact number is 160 something in the placebo group and less than 60 in the vaccinated group, he said. This would equal 63%, not 78% efficacy. CoronaVac appeared to work as well in the elderly as in other age groups, the researchers added. The lack of data, let alone the efficacy disparities, predictably led to immediate skepticism. Until they show us these numbers, it is nothing more than an empty announcement, tweeted epidemiologist Denise Garrett, a vice president of the nonprofit of Sabin Vaccine Institute. Details have been in short supply in the initial efficacy trial announcements by the COVID-19 vaccine makers as well. But researchers who runs one of the 16 sites conducted the CoronaVac trial in Brazil, Espers College and the University of Sao Paulo's main campus, says even study investigators still don't know all the data. Carlos, who spoke with Science after the press conference, is happy about the results. We know that 78% is true, he says, but he is frustrated that we don't have the granularity, my bad, of it. As for the case numbers, Covas mentioned, Callis says, I couldn't understand these figures. Now, I'm going to stop right here. Excuse me. And now I don't want to go any further than this because we know it's murky. But here's a key point. Researchers testing CoronaVac in Turkey apparently faced no such hurdles. On the 24th of December, they revealed preliminary data showing 26 COVID cases out of 570 participants who received a placebo and 3 cases in the 752 vaccinated volunteers. That translate to 91% efficacy and no serious safety issues surfaced. The next analysis will occur at 40 cases, says Murat Kovor, a researcher at Hacettepe University who was helping run the study. Asked about the restriction of Brazil researchers, Akovi says there is no such contract with Sinovac about releasing data. Okay, so there's some murkiness going on. All right. If you want to read the rest of the article, which ain't much left of it, feel free. Now, here's another article. How CoronaVac's efficacy, new virus strands will affect Indonesia vaccine blitz. Remember, Indonesia is a part of the trial. Brazil is a part of the trial. Turkey is a part of the trial. So I went to Indonesia to find out what I could find out from Indonesia to see what they're saying about the vaccine. This report says, while the health ministry has given a fresh start ahead of the new year, a new leader is at its helm. Concerns over the efficacy of a pre-order COVID-19 vaccine and the discovery of more infectious strain of the coronavirus have put Indonesia vaccination plan in the spotlight again. Now, the country has secured 125.5 million doses of the Chinese firm Sinovac's CoronaVac vaccine candidate, despite the lack of efficacy data from the company or the late-stage trials being conducted in Bandung, West Java. Efficacy in the case of the vaccine development is the level of effectiveness that potential vaccines show in a controlled laboratory environment. Last week, a Brazilian health authority said that its trial of the self-same vaccine in the South American country showed an efficacy reading between 50 and 90%. Reuters reported as many as 13,000 participants were involved. Now, the revelation came shortly after researchers in Brazil said that just a few days prior, the efficacy in Sinovac's vaccine was over 50%, even though they stopped short of disclosing full results of the company's request, prompting transparency concerns. The full data set from the Brazil trials is expected to be revealed on January 7th. Reuters also reported that Turkish researchers found that CoronaVac's efficacy was a high 91.25% days after the interim trial results were revealed based on the data of 1,300 of 17,000 participants. All right, so we on that same fine line. So they have some diversity in the trial, but they also have skepticism, and they're saying it's somewhere around 50%. Lo and behold, new data is released. All right. New Brazil data shows disappointing 50.4 efficacy for Chinese CoronaVac vaccine. Why am I showing this? It's because I want y'all to know how transparent Pfizer and Moderna are. They have been absolutely transparent with us during this whole entire process and providing additional information that you can see in other countries is not happening regarding the vaccine. This is not to cast doubt on the CoronaVac, Chinese vaccine. This is clearly showing and establishing the differences between the companies and what's going on with us in America. All right, so coronavirus vaccine developed Chinese Sinovac Biotech was just 50.4% effective at preventing symptomatic infections in a Brazilian trial, researchers said on Tuesday. Remember, this was published on the 12th. What's today? 12th. All right. Barely enough for regulatory approval and well below the rate announced last week. Last week, they reported higher numbers. This week, they're not there. The latest results are a major disappointment for Brazil, and the Chinese is one of the two of the federal government that has lined up to begin immunizations during the second wave of the world's second deadliest COVID-19 outbreak. Several scientists and observers blasted Bhutan Biomedical Center for releasing partial data just days ago that generated unrealistic expectation. The confusion may add to skepticism in Brazil about the Chinese vaccine, which President Jair Bolsonaro has criticized, questioning its origins. We have a good vaccine, not the best vaccine in the world, not the ideal vaccine, said microbiologist Natalia Pasternak, criticizing Putin's triumphant tone. Last week, the Brazilian researchers had celebrated results showing 78% efficacy against mild to severe COVID-19 cases, a rate they later described as clinical efficacy. They said nothing at the time about the group of very mild infections among those who received the vaccine that did not require clinical assistance. Ricardo Palacios, medical director of the clinical research at Butantan, said on Tuesday that the new lower efficacy finding included data on those very mild cases. We need better communicators, said Gonzalo Vicananito, a professor of public health at the University of Sao Paulo and former head of Brazilian health regulator Anvisa. Piecemeal disclosures about Chinese vaccines trials globally have raised concerns that they are not subject to the same public scrutiny as U.S. and European alternatives. I'm going to repeat. Piecemeal disclosures about Chinese vaccine trials globally have raised concerns that they are not subject to the same public scrutiny as U.S., the United States, that's North America, this is United States of America, and European alternatives. Let that digest and sink in. Palacios official in the Sao Paulo state government, which funds Butantan, emphasized the good news that none of the volunteers inoculated with coronavac had to be hospitalized with COVID-19 symptoms. Public health experts said that alone will be a relief for Brazilian hospitals that are buckling under the strain of surging caseloads. However, it will take longer to curb the pandemic with a vaccine that allows so many mild cases. It's a vaccine that will start the process of overcoming the pandemic. Now, let me catch y'all up. It's a couple of people that just joined, and it's cool. Peace to everybody that just joined. You know, Elder P, Jerome, Zane was good. Aronde, Pure was good. Appreciate y'all hopping on. The Chinese releases a vaccine called coronavac. The vaccine contains a dead, weakened strand of SARS-CoV-2, or what we know as COVID-19. It has the dead virus in it. Now, they inoculate people in it, and they're trying, you know, they're in a mild stage trying to prevent severe. They claim the efficacy was 78%. They did not release any data that was cordial enough to satisfy those who were looking to scrutinize the data. All right, everybody's caught up now. Researchers at Butantan delayed announcement of their results 3 times, blaming confidentiality clause in the contract with Sinovac. In the meantime, Turkish researchers said last month that coronavac was 91.25 effective based on the interim analysis. Indonesia gave the vaccine emergency use approval on Monday based on the interim data showing it is at 65%. That's a big difference. So Turkey has 91.25. Indonesia has 65%. South America, Brazil in particular, they got 50%. But Moderna and Pfizer have over 94% efficacy. And they are mRNA vaccines. This is a conventional vaccine. Putin officials said the design of the Brazilian study focuses on frontline health workers during a severe outbreak in Brazil, and including elderly volunteers made it impossible to compare the results directly with other trials of the vaccine. Still, COVID-19 vaccines in use from Pfizer Inc., partnered with BioNTech, and Moderna improved to about 95% efficacy in preventing illness in their pivotal late-stage trials. The disappointing coronavac data is the latest setback for vaccine efforts in Brazil, where more than 200,000 people have died since the outbreak began, the worst death toll outside the United States. Brazil's national immunization program currently relies on the CoronaVac and a vaccine developed by Oxford University AstraZeneca, neither of which have received regulatory approval in Brazil. Anvisa, which has stipulated an efficacy rate of at least 50% for vaccines in pandemic, has already pressed Putin for more details of the study after it filed for emergency use authorization on Friday. The regulators said it will meet on Sunday to decide an emergency use request for CoronaVac and the British vaccine. AstraZeneca failed to deliver active ingredients to Brazil over the weekend, leaving the government scrambling to import finished doses of the vaccine from India to begin inoculations. Ladies and gentlemen, this is the reason why we have not gotten FDA approval from AstraZeneca. It was rejected. So I want to ask you a question. Based on what I just read and what we know, well, many of you don't know. So let's just say that after Moderna got its EAU, AstraZeneca was next in line. However, the FDA board rejected the EAU based on the data and told them that they need to do better with this. They need to have better trials, better studies, better data. They rejected AstraZeneca, or we would have 3 mRNA vaccines right now. Okay? So what I'm about to ask you shouldn't be difficult for you to answer. Do you feel that the FDA has your best interest at heart? Or do you feel that they don't have your best interest at heart, and you don't feel that Moderna and Pfizer's efficacy rates are good enough for you to consider taking a vaccine, and you just rather risk your chances at catching COVID-19 over and over and hoping that you would gain some type of herd immunity, which you won't, or gain some type of immunity based on that, or just chancing your life at dealing with whatever problems that may exist down the line. I want to know how you feel and what you think. Or would you rather have this the CoronaVac vaccine from China? Would you rather have that vaccine versus the mRNA vaccine from Pfizer and Moderna? Because remember, people said the ingredients, they had issues with the ingredients. But Sinovac has the coronavirus in it, a dead strand of the coronavirus in it, and they're administering it to people. And its efficacy rates may be 50%, which is 45% less than the mRNA vaccines. So I want to ask you again, do you trust the FDA? Think about what you are answering. I mean, think about what you're saying before you say it. I see Teddy says he trusts the FDA. One reason I know why, because he's not cowardly. Now, I do know there's a delay. So I'm going to wait a minute. And then I'm going to see what's going on with everybody. Elder Pete said vaccine mRNA now. Aminata and Zenga, what numbers you don't trust? And Zenga, what numbers? What you got going on, J&J, Johnson & Johnson is still in trials, bro. So really there's no data that we could, that I can't catch wind of earlier on to be able to answer that. Okay, so let me ask you this, Nzinga. You said you don't trust the efficacy. Do you know how efficacy is determined? This is a fair question. Rondé said he in the line. I trust the FDA and Moderna. I'm with Chavis. Moderna, hey, guess what though? In other news, Moderna is showing, and I know many of y'all may not know this, but I dropped this in the Pseudo Killers, you know, and of course the Mossy Warrior Clan and everywhere else. But I dropped some information showing that Moderna is showing at least a year of efficacy. And let me, I'm gonna do y'all a solid, and I'm gonna bring that up on the screen too. But I really wanted to get this information in before we move or progress a little bit further out. And then I'm gonna deal with Sister Nzinga's understanding of, you know, stuff. Let's see if I can help answer questions, I guess. If I can answer her question. Well, do what needs to be done for her. And I'm not gonna make this video too long, but I just wanted to put y'all up on game regarding what's going on with the Chinese vaccine. And I know many of y'all never really heard of that. So all right, so give me 1 second. Let me pull this up, and I'm gonna give this to you right here. So let's deal with how efficacy is determined. Let's see if we could get her under. I don't think Moderna has our best interest. I would rather wait for another country to come up with a vaccine. What country? Hold on, time out before I do this. Kisu, what are you saying? Why would you wait for another country to create something? I just read another country. I read 3 actually: Indonesia, Brazil, and Turkey. They are dealing with a whole nother country's vaccination, CoronaVac. AstraZeneca is another vaccine, mRNA vaccine, not created here, but from somewhere else. AstraZeneca hasn't proven high efficacy rates. The FDA rejected it. Sinovac will never get approved here. A Chinese vaccine, they're not going to deal with it. So, Kisu, I want to ask you, what country do you feel safe making a vaccine for you? And what measures would you go to prove that vaccine would actually work? Oh, okay. But I don't trust the percentage of the FDA gave. All right, so let's deal with Nzinga real quick, and then we'll get into the Moderna. So, what defines a infectious COVID-19 vaccine? This is a review of the challenges assessing the clinical efficacy of the vaccines against SARS-CoV-2. This is a great journal. This is something that you should have. I want to provide this for Sister Nzinga. Please take your time and read that. If you got issues, questions, problems, concerns, or whatever, we can go from there. Now, I'm gonna read the summary so I can help you get a little understanding, and then I'll get into the conclusion because I don't want to bore y'all with all this information. Now, in the summary, the novel coronavirus, severe acute respiratory syndrome coronavirus 2, SARS-CoV-2, has caused more than 1 million deaths in the first 6 months of the pandemic, and huge economic and social upheaval internationally. An infectious vaccine is essential to prevent further morbidity and mortality. Although some countries might deploy COVID-19 vaccines on the strength of safety and immunogenicity data alone, the goal of the vaccine development is to gain direct evidence of vaccine efficacy in protecting humans against SARS-CoV-2 infection and COVID-19. So the manufacturer of infectious vaccines, vaccines can be selective upscale. I'm not going to read all of that. So I'm gonna go down to the most important part, for Sister Nzinga. Now, however, the most important efficacy endpoint, a protection against a severe disease and death, is difficult to assess in phase 3 clinical trials. In this review, we explore the challenges in assessing the efficacy of candidate SARS-CoV-2 vaccines, discuss the caveats needed to interpret reported efficacy endpoints, and provide insight into answering the seemingly simple question, does this COVID-19 vaccine work? All right. So I gave you the source so that I don't bore you with all of this information. Defining vaccine efficacy. All right, this is important. I'm gonna read the first paragraph and then I'm gonna move on. Many different endpoints are used in vaccine research to define efficacy depending on the pathogen, consequences of infection, and transmission dynamics. Often outcome data from, listen to me very closely, outcome data from randomized controlled trials, RCTs, are presented as a proportional reduction in disease between participants who were vaccinated and control participants to calculate the reduction that is attributable to the vaccine. Outcomes might include reduction in infection, i.e. assessing sterilized immunity, severity of resultant clinical disease, i.e. assessing disease-modifying immunity, or duration of infectivity. Such RCTs represent best-case scenario of vaccine efficacy under idealized conditions in particular populations and provide key data necessary for vaccine licensure. However, vaccine efficacy does not always predict vaccine effectiveness. They're two different. The protection attributable to a vaccine administered non-randomly under field conditions. For example, the effectiveness of rotavirus vaccines in children in low-income and middle-income settings was lower than the efficacy observed in children in high-income countries. RCTs might not predict protection gained indirectly from herd protection, sometimes called herd immunity. Following widespread vaccine deployment, equally, RCTs done in particular age group or geographical settings might not predict effectiveness if the vaccine is more widely deployed. It is possible that alternative vaccine platforms or the additional of adjuvants are required in adequate immunogenicity in older age groups as for influenza vaccines. For this reason, prospective studies of vaccine effectiveness in real-world scenarios post-licensure are routinely needed. All right. So you have the study. Here's the study. Okay. They have a chart here. Downloadable, you can view larger. Here's the chart. Personal protective equipment, infectious dose. So you have here human, rate of transmission, likelihood exposure, occupational risk, physical distancing, SARS-CoV-2 exposure. Then you have that. Then you have SARS-CoV-2 infection. Then you have the individual risk factors, sex, ethnicity, age, comorbidities. SARS-CoV-2 poor outcome there. So that's what that image is all about. Okay. Now they continue the study and they go through a model. See here, you have age groups per 1,000 people, data over the last 6 months, people per day over 6 months from the ages of 20 to 29, 1880 affected, symptomatic infections, 3154. Hospital admissions, 183 to 930. Death, 619 to 130. All right. These double numbers are probably going to get you to the point of who vax and non-vax, okay, in the study. All right. 80 years, same results. Other numbers right here. It says the calculate, you can go through here and read it real slow. Okay. What makes the efficacy data valid and trustworthy is that it's in a double-blind placebo. It's in a controlled study, meaning they got the same number of people that they got vaccinated are also in the. So if I got 30,000 people, I got to have 15,000 in the placebo group and 15,000 in the vaccinated group. I give people in the placebo group a shot. I give people in the vaccine group a shot. All right. Now, I study them over a period of 90 days. See what happens, tell them to live their normal lives, do whatever they do. After they've been after they all been vaccinated, we start collecting data based on how people are responding. Like, okay, how's things going? Blah, 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 blah. How many people actually got sick? Who did what? Where is this coming from? What were the adverse effects? What about allergies? So on and so forth. Right? So we have that information. Okay. Now, once we get closer down to that time, we start to uncover how many people were hospitalized over that 90-day period, how many people developed some type of reaction, how many people actually contracted SARS-CoV-2, how many people died, how many people had to be sent back to the hospital, how many people developed swelling at the injection site, how many people had all the reactions that you can get in the world. We document all of that. This is what happens. And on the flip side, the FDA does not determine the data. The independent people involved in the trials present the data. There's no hidden agenda. The data is the data. The FDA looks at the data. The government looks at the results. Before an EAU is issued, the government or the FDA has to review the results. Once they review the data and they look at the risk reward, they determine among a group of how many of the people that are a part of that board, because they have to approve every vaccine possible that they're going to have on the market for us to take. But the EAU ain't for us. The EAU is for emergency use only. Right now, it's emergency use. So they vaccinating frontline workers, people over the age of 75. Now today, you had Trump come out and say people over the age of from 65 and up need to be vaccinated. We still ain't in the good, because guess what? After the 65, they're gonna go down to the 50s. After the 50s, they're gonna go down to the 40s. We are months and months and months away from us even being asked if we want the vaccine. So let me go to the conclusion. Now, the assessment of the efficacy of the vaccine is complex for many diseases, but particularly so as the sorry, y'all. Uncle was texting me. Assessment of the efficacy of vaccine is complex for many diseases, but particularly so in the case of SARS-CoV-2, where the fundamental understanding of the pathogen is evolving. Multiple vaccines are being tested worldwide in early phase studies, and some vaccine candidates are already in a phase 3 studies assessing efficacy. It is probable that there will not be a single vaccine winner. Diverse platforms and technologies can offer different strengths and be relevant in distinct epidemiological contexts. Additionally, there will probably be insufficient supply, at least initially, of a single vaccine. However, collaborations and standardized approaches for assessing different efficacy endpoints will be important to allow meaningful comparison and ensure that the most effective candidates are deployed. Following deployment, well-supported pharmacovigilance studies should be established to ensure the ongoing evaluation of vaccine safety. Now, the efficacy rate has nothing to do with the effective rate, okay? We know the vaccines show high efficacy rates. The effectiveness continues to be monitored on every vaccine you know. Every year, these vaccines are under scrutiny to see if it can handle, these mutating pathogens. All right? Because viruses adapt. Yes, adaptation is big in viruses. Natural selection teaches us that. All right, so I know I'm probably in the chat or something by now because he laughing at me right now. But anyway, so that I'm not trying to answer that question for you or make up your mind, Sister Nzinga. I'm only trying to give you enough informed decision to help you advance your information and understanding of what and how efficacy rates are determined based on the data. So please, when you have some time, take about 30 minutes, not even really 30 minutes, but about 10 or 15 minutes of your time, read the article that I put in the chat for you and see if you can understand how efficacy is determined. And maybe that'll help answer some questions for you. All right. Now, to change it up, before we kind of hop off, because I did kind of go over on what I wanted to go over as far as time constraint, but I wanted to leave y'all with this. It's a 2-minute read. 2-minute read. And Moderna says COVID-19 vaccine immunity to stay at least a year. So if you get the Moderna vaccine, I can't speak for Pfizer. For those of you who have the vaccine, I understand, what I'm saying? I can't make it mine up. But we know a Black woman was behind the creation of the Moderna vaccine. For all y'all pro-conscious folk out there that think, Black is the best thing going. And you know what I'm saying? And you can get behind somebody Black, but you can't get behind somebody white. Well, Moderna is your vaccine. This is your vaccine. And it's saying a year. So how do they determine that? Where are they getting this data from? How can you answer that question right now? Is it because you was already working on this vaccine a year ago when the pandemic kicked off? Let's see. Let's see what's going on. So immunity for Moderna's COVID-19 vaccine should last at least a year. The company said on Monday at a JP Morgan Healthcare conference, the drug maker said it was confident that the messenger RNA technology it used was well suited to deploy a vaccine based on a new variant of the coronavirus, which has emerged in a handful of countries. The company's vaccine and mRNA 1273 use synthetic mRNA to mimic the surface of the coronavirus and teach the immune system to recognize and neutralize it. Moderna said December it will run tests to confirm the vaccine's activity against any strain. Confident. The company said on Monday it expects to deliver between 600 million doses and 1 billion doses of its vaccine in 2021 and forecast vaccine-related sales of 11.7 billion for the year, based on advanced purchase agreements signed with the governments. The team feels very confident with the track record we have now that we are on track to deliver at least 600 million doses, Chief Executive Officer Stephen Bancel said. And that's all you get right there. They kept it short, sweet, and to the point. I still would like to see the data. I believe in the efficacy of Moderna being at 95%. As far as it extending out to over a year, that is to be determined. Now, I know that we have people who have been administered the vaccine that has had it for quite some time. You're talking phase 1 trials, phase 2 trials, phase 3 trials. But before you got to phase 1, 2, and 3, you had smaller groups or testings or people that volunteered before trials began to kick off that actually got the Moderna vaccine that are walking around here right now that, have shown immunity against SARS-CoV-2, COVID-19. And they could be using that in that small sample size case study to determine, hey, look, this is looking good. These people are out in the population. That could be it. However, I'm going to wait on some more information before I rock with that 1 year. All right, let me catch up with everybody in the chat. I see Nunu is late to the show as always. With all the information available at this point, I think people just want to hold on to their boogeyman views. That's true. I believe I can believe with that. Okay. And Zinga retracted my statement, not knowing that it wasn't only China on the list for coming up with a vaccine. I missed the Turkey. Yeah, nah, but hold on. Let's put it out there. We got a vaccine. Everybody making a vaccine right now. Everybody got a vaccine right now. Let's see if we can go through this together. It ain't just, it's just it's a pool of people that's using the same, pretty much the same understanding, because they've been dealing with mRNA vaccines for, a long time. All right, so let's see if we can get a list. Here we go. You got Moderna, you got CanSino, you got Innovor, you got Sinovac, which we heard about. This deal with this dead strand. You got BioNTech, you got AstraZeneca, Sinopharm from Beijing, which we know that, and the Sinovac or CoronaVac is similar. You got Novavax, you got Gamaleya Research Institute, you got CureVac, you got Clover Bio, you got Johnson & Johnson, you got Sanofi, so you got all these people right now that are making vaccines. Now, there may also be others, because you got some people that's trying to work on a nasal spray. You got some people that's working on a needleless injection. You got them trying to see if they can also make some type of like drug, pharmaceutical prescription type of stuff as well. But I don't know how effective all of those will actually be. Right now, BioNTech and look, everybody got their first authorization. They got authorization. They got authorization. They got authorization, but not in America. This is not in America. Let me show you. This ain't in America. AstraZeneca, the FDA haven't approved it. They rejected the approval, use of AstraZeneca in America. They haven't touched the Beijing or any of the Chinese drugs, Sinovac or this one. And this one, not in America either. We're looking at Johnson & Johnson, BioNTech, Pfizer, and Moderna. Okay, AstraZeneca was supposed to come behind Moderna, but the efficacy rates and the lack of data, good data that the FDA was looking for wasn't present in their case studies, and the FDA said no to AstraZeneca. So next up is Johnson & Johnson, and that could be a month or two out. We could be a month or two out from Johnson & Johnson. Now, if Johnson & Johnson turns out good efficacy rates, we will walk with Johnson & Johnson very slowly, and we will figure out what's going on with that. Now, there go Moderna and its development timeline. The vaccine candidate selected. It was selected once they mapped the genome. Their first volunteer was in March. Okay, this is why they saying efficacy could be a year. Walk with me, my people. Walk with me. They began the vaccine. Remember, between this time, then they got to dealing with they had their first volunteer was in phase 1. Look, 316. And they had people before that, but 316, phase 1 data disclosed 2 months later. First volunteer given phase 2, May. Phase 3 began in July. They were running them at the same time, y'all. Almost at the same time. Before one would end, another one would begin. And then they just kept getting the data. Okay, there we go. Until we got to the 18th of December and got the EUA. I wouldn't even call that dude a nurse. Oh, my bad. I got this this Mac mouse. If you swipe left or swipe right, it'll on you. All right, so I can jump to companies. Let's go to BioNTech. Here we go. March 17th. Right, look, because this is grouped. Now, the difference between Moderna, you've seen the American flag with Moderna. You got American and German companies are working together for this vaccine. And you see the same thing. But they first volunteer started in Germany. Then they had some UK authorizations and all. They got all that right here, US authorization, and then the UK authorization, right? Going right there. Let's go to Johnson & Johnson. That's another. This is another US. Because, man, look, you ain't gonna be a part Chavis. You ain't getting in the Johnson & Johnson trials, bro. They ain't ready yet. They ain't ready yet. Look, they had planned to recruit 60,000 people, but the pandemic made them draw back on how many people that they needed to have a part of their trial. That's why they ain't call you. So listen, this is a different type of a vaccine than Pfizer and Moderna. This is a non-replicating viral vector. Okay. Look, when I go to Moderna, watch what Moderna say. It says messenger RNA. When I go to Pfizer says messenger RNA. When I go to Johnson & Johnson, it says viral vector, non-replicating. Look, the first supply would be available early 2021. So they really ain't even where they need to be yet, bro. Look, phase 3 study to resume. Remember, they had issues. So let's see, look, protein-based, Merck, replicating viral vector, DNA-based. I don't know how that's gonna go. Inactivated virus, like I told y'all. AstraZeneca, non-replicating viral vector. That's why it ain't getting no play in America right now. Protein-based. Inactivated virus. So they have vaccines out there that will have an inactivated virus, and then they have other ones. CureVac. We don't know nothing about this here, but Germany is involved. We do know that. So here's another one. They just now really getting into their studies. So we'll see what comes of them. You know, protein-based. And that's that on that. Give me the mRNA vaccine. It's a wrap. I did way too much research, studying, and understanding of how mRNA vaccines work, and that's how I'm rocking. I want messenger RNA. Give me the synthetic. Anybody that want this, I'm gonna put this in the chat. Yep. There you go. Let's see. Jamal says the conscious community only vaccine is Nurse Inky's Mama Tomix. The efficacy is non-cipher. What you crying? So, anybody got anything else? Adenovirus. Yeah, but you talking about stuff ain't even started yet, bro. I ain't dealing with none of them. I don't even care. I don't care about another vaccine, not at all. So yeah, man. Let's see. I think I'm trying to go jump on Stinky over there on that other channel, so I don't know how this gonna rock. Let me check my messages. Let me see. I'm gonna hit up Unc live. You watching Unc? I'm calling.
Yo.
You heading over there?
Yeah, I'm going over there right now.
All right, I'm finna send the people over there. I'm gonna drop the link in the chat for the people.
You say what?
I'm gonna drop the link in the chat for the people.
What link?
Nah, I'm finna put yeah for where you going.
You going over there? Or you ain't going?
Nah, I ain't hollering at Inky today.
Yeah, I know, yo. Hey, these niggas sleeping.
Yeah, let him live. Let him live. We already got him anyway. He locked in. Yeah, he locked in. Yep, the paper killed him, and he didn't read the rest of it. He locked in. Yep. Nah, yeah, he done. Yep. All right, I'm still live. All right, I'm finna send you a link. Here. Now I'm finna send you my link. All right. Save myself a headache. Going over there fighting with him. Yo, it's crazy, yo. Tay was over there talking all that, man. I ain't going over there. Nah, bro, I ain't waiting on no dang on vaccine that ain't even came out yet. I want the Moderna. Run me the Moderna. Go on, give me my 2 doses. Let me get on out of here. What's up, y'all? What's good? Man, y'all ain't got no questions, man. Come on, man. I can't be that clear, yo. Hey, y'all know who was the first laboratory in the U.S. to detect SARS-CoV-2 variant? Nah, I'm not going over there. Sorry, you're going to have to go laugh on your own merit, not me. I'm going to ask y'all again. Do y'all know which laboratory was the first in the U.S. to detect the SARS-CoV-2 variant? VOC 2012. Do y'all know? I sent him my link. I don't know if he's going to hop on, though. Before I get off, man, I want to know. I'm trying to see if I'm going to hop on. If he hop on, I'm going to rock out a little bit longer. If you're not going to hop on, I'm going to get off. But can somebody answer my question? Don't be Googling. He said, Dex, I'm going to wait and see what y'all come up with. I'm waiting. Nah, he ain't on, sir. I wasn't going over there either. Nah, he was talking about the what's your boy name from Philly? The one we was on the other day. Him from Philly. Y'all not gonna answer the question? Pure said Dexter, Harvard, where the first lab was. Nah, Zane, who was the first? DC said U.S. Customs. Teddy said Oxford. Nah, all y'all wrong. Who? Let me ask it again. Which laboratory was the first in the U.S. to detect the SARS-CoV-2 variant VOC 2012-01? Who was it? I go on. Whose laboratory detected it? The new variant. Oh,
I'm
do
here.
you
What's
know
up?
what's up? You know whose laboratory detected SARS-CoV-2 variant VOC 2012-01, which is the UK variant. You know which laboratory did it?
Yankees. Nah, who laboratory did it?
Well, of course, where was it found at? Where was the new
In
variant?
Europe. In Europe, right? Or South
No,
Africa?
and in the US. Where was it found at first in the US?
Oh, I don't know. What was it? I ain't know. I thought it was in Europe first.
Yeah, it was in Europe first, but I'm saying detected here in the US.
Oh, yeah. Oh, who lab? I don't know who. Where was it found at first? Yeah. I ain't up on that.
Yeah, so Colorado.
Oh, okay. All right.
So the Colorado Department of Public Health, they were the first people to detect the new variant. And yeah, they were the first. Now, let me give y'all this. Let me give y'all this from the CDC, and then I'm gonna give y'all the post from Washington Post. There's another source regarding the information, just so y'all know what's going on. Boom, there go two for you right there. What was they talking about over there?
I ain't gonna go over there. I let them live, yo. I
Okay.
didn't feel like being silly. I think I was silly enough for 53-year-old for 1 week.
So
they just try to get us upset, yo. That's the only way they win, yo. When niggas dive off the scientific thermonuclear jets, yo, then when we throwing rocks and bottles, yo, that's when they did best, yo. But to have a good conversation like this, yeah, they always did. He over there talking about sources. We started the source shit. I don't get them start that source shit. Then talking about some 30-year-old sources, nigga. We were saying up-to-date sources, nigga. Fuck around with this nigga, yo. Crazy, right?
Yep.
Yeah, it's crazy. We use up-to-date sources, up-to-date available material because we're secondhand researchers, dog. Well, I'm gonna speak for myself. I'm a secondhand researcher, so that means I have to rely on the experts because I do not have a lab.
Right.
Yep, or an electron microscope. So it's my job to make sure that people know how to access.
You can't go to California and get, your boy.
Get who?
Go to Beverly Hills. You can't go to Beverly Hills and pull up on P. Diddy and use his electron microscope.
Nah, like you still be talking about polite. Yeah, he said he spent $1 million and got $1 million room to put it in. That's $2 million. And then a special floor. Never 500,000. Yeah. It's funny, yo. Yeah. I'll go these idiots. I be wondering how they make determinations, yo, without an electron microscope, yo. It's crazy, bro. Yeah, people believe that shit. People really think they can defeat science with pseudoscience.
Yep.
Yeah, it's crazy. Wow.
Hey, so how do scientists figure out the efficacy of a vaccine?
They test that shit on the people. They use that placebo joint. Then they see how effective it is, and then they do the ratio. Yeah, they see how many people actually caught it in the studies. Yep, and then they know who they gave placebo to, and they know who they gave the real shit to.
You trust
they work out the numbers.
You trust the data? You trust the data that comes out of the results?
But that's the only data we got. And even when the pseudo try to fuck up the data, they still using the scientific data to twist it. And they didn't do the study. Inky and them didn't do the study. The pseudos didn't do the study. The people who acting like this shit wasn't real didn't do the. Where's your numbers at so we can see? So show us 40,000 people, okay? Give them the placebo, mix and match, however you do it, and then tell us what it is, and then we'll listen to you. Until then, shut the fuck up. Simple, bro. Sometimes I think we complicated, yo. They don't have an answer for us, bro. Yeah, they don't. It's crazy, Shawn. I mean, we be so busy trying to teach yo that we forget that these niggas don't have no data. You feel me?
Mm-hmm.
Yeah.
They ain't never got on. We gotta do all the storing and pooling.
You said what?
We the ones got to store and prove all the time.
Yeah, we really don't, because they're using the shit we use. They cherry picking the experts we got.
Yeah, they are. So based on the data we have, you like Moderna and Pfizer's efficacy rates?
Of course, that's the only data we got.
Did you see the info on that vaccine that Turkey, Indonesia, and Brazil using? They're using a deactivated strand of COVID.
Oh, they're gonna use the virus. They're gonna use the second generation joint.
Yeah, they're using the virus. Not they going.
No,
They ain't using it in the EAU.
How it's working. But I mean, that's a good job with the second generation, though. Ain't nothing wrong with the second generation.
All right. Uncle fell off. We'll wait till you come back. Uncle on trial. We got Uncle on trial, y'all. When he come back, we're gonna figure it out. He said he ain't got no problem with it. Second generation. No problem with the second generation. Man. What's up? Yeah, hey, can I get some lights? Can we share the show? Uncle just took a phone call. Yeah, he'll be right back. It took him out. Hold on, before he even asked me. Before he asked me. Email. What's up, y'all? I see 30 people in the building. Can we get some light? We got Uncle Cat in the building. He just took a phone call. Well, his phone died, one or the other. All right, so while we waiting on Unc, let's get this in real quick. All right, so here's what I was talking about earlier, and hopefully I answered all the questions. So we know the UK variant came from the United Kingdom, say over there, England, London, England, somewhere, right? But the first case of that virus that showed up, variant showed up in Colorado. All right. And so in this summary, it basically says a new variant strand of SARS-CoV-2 that contains a series of mutations has been described in the UK and became highly prevalent in London and Southeast England. Based on these mutations, this variant strand has been predicated to potentially be more rapidly transmissible than other circulating strands of SARS-CoV-2. Although a variant may predominate in a geographic area, and the fact alone does not mean that the variant is more infectious. Scientists are working to learn more about this variant to better understand how easily it might be transmitted, and whether currently authorized vaccines will protect people against it. At this time, there's no evidence that this variant causes more severe illness or increased risk of death. Information regarding the virologic, epidemiologic, and clinical characteristics of the variant are rapidly emerging. CDC, in collaboration with other public health agencies, is monitoring the situation closely and will continue to communicate. They're being a little bit too transparent. All right. So, it says, does this variant have a name? Yeah, we know it has a name. Why the variant has been in the news recently? We know why. Why has a variant emerged in the UK? We don't know. By chance alone, variants often emerge or disappear, and they may be the case. It may be the case here. Alternatively, it may be emerging because it is better fit to spread in humans. Right? Remember, zoonotic virus went through something that went through something that went through us and then went back to, animals or whatever. So you're dealing with back and forth, right? So this new variant is just something that could communicate a little bit better from human to human transmission. Okay, solid sand. So we seen the variant in the United States. There you go right there. And has not been identified through sequencing efforts in the United States, although virus have only been sequenced from about 51,000 of 17 million US cases. Ongoing travel between the UK and the United States, as well as higher prevalence of this variant. Current UK infections increase the likelihood of importation, given the small fraction of US infections that have been sequenced. The variant could already be in the United States without having been detected. So, that's how they jump out, say that. Now, this isn't new. This is from December 29th. We have more up-to-date and latest information regarding that. So this is why it sounds like I'm speaking like in a different tense than need to be. We know South Africa has a different variant than the UK variant. And we have this understanding that, we really don't fear variants. We shouldn't. We don't know really what all the fuss is about. Viruses mutate. And understanding this adaptation and mutation, it goes from there. This I hate saying this, but I gotta say it. But this what makes Ank's argument about evolution prevalent. It's because you have to deal with natural selection. You have to deal with adaptation, and you have to deal with mutation. Period. You're talking about, Ank's lane. This is in Ank's lane. This also helps. Evolution helps us understand viruses better. Hey, man, I don't know what y'all saying in the chat. I ain't no informant. Pure. I'm not listening. Tanzania data ain't even accurately reporting. We dealt with that already. African countries are not reporting accurate data. Why would I talk about that? You always want somebody to talk about something that we don't even really talk about. Kids do that all the time. Tanzania, they got to show and prove the data. They don't have the technology to actually educate us properly on their data. We have a hard time contracting that. Because most people are saying why it ain't spreading in Africa. And then we go to find out that it's actually spreading in Africa, but they don't have the tools to update the information to give it to us. Man, Tip ain't no informant. He ain't telling nobody. Yeah, in some African countries we can't get actual data. What you mean how we find out? Because we read it on the pseudo killers. The embassy was reporting information and all of that. That's how we know. Ask me how we know. Look it up. What you mean how we find out? That's how we found out. We researched it. We looked it up. What about the hold on? What's Zane? I don't know what Zane's talking about. What you talking about, Zane? What you saying in particular? Oh yeah. Oh, viruses and evolution. Yeah, you know that. Yeah. Okay, so you remember when I was playing the video of the black dude from dang, I forgot his name now. Oh, I gotta find the video. But you remember I was playing the video? Yeah. You gotta look at the evolution of viruses. Remember we was doing that, the evolution of viruses? We had one more little video to go on that. So when I show you, you're gonna kind of understand what's going on with that based on this. See what I'm saying? See, viral evolution refers to heritable genetic changes that a virus accumulates during its lifetime, which can arise from adaptation in response to environmental changes of the immune response of a host. Because of their short generation times and large population sizes, viruses can evolve rapidly. And when you're dealing with that, you got to understand you got to understand evolution. Because viruses do what? Mutate and adapt. What you mean the CDC is wrong? What you mean the CDC wrong? They going on stuff based on what they know. They don't have anything. The CDC telling you don't travel. They saying, listen, they said Tanzania's in a level 4, very high level of COVID-19 in Tanzania. What you mean post the link? I don't need to. It's on the pseudo killers. Nahisi got tired of you, Keisha. They on the level 4. So if you're saying that they only got so many, why would they be on a level 4? I'm telling you right now that they really don't have all the information that's necessary, because the latest information is always behind, coming from African countries. So if you're saying that somebody got 500 and something, I don't even see that in I don't see that data at all in anything. You look at CDC Tanzania. I did. That's where I go for the info. Well, yeah, then you got the answer then. Like he said, they stopped reporting their data last year.
Yeah, my phone. You know, I'm on a cell phone, yo. But
yeah.
I had to rethink my concept, yo. You made me rethink this shit.
What you talking about?
Just when I was thinking about going over there and beat them niggas, that shit beat myself up, yo. Because they just period, like people on everybody who talking crap right, about what we doing, how we doing it. They have no data, so we can look at. They got conspiracy, and any data that they can come up with has to come from scientists, yo. Simple as that, bro. Like, don't talk to me about nothing. The world works off of information and data and mathematics and science. It don't work off of what you believe and what you hope. You feel me? It just don't work off of that, yo. So it's, it's funny to me, yo. Super funny, bro.
Yeah. But yes, I was saying earlier to everybody, just trying to help them understand how relevant evolution is in understanding actual viruses or the origin of viruses. Like, in order to understand viruses, you got to understand evolution, because viruses adapt and they mutate.
So, and you got to understand proteins, right? And the origin of proteins and how they mutate, how proteins mutate. You feel me? So it's a stage, it's a building block, it's chemistry, right? It's the whole piece. And so since since people around us deny all that, how do we really expect them to understand the virus?
Correct.
Yeah, we've been on this for the last 10 years. I don't know how long I know you, Shawn.
It's been a while.
Right. You came into this thing fighting for science, yo. You know what I mean? Like, we come into this thing fucking with science, yo. So we been ahead, yo. And there was a reason why we did it, yo. So we can understand the world around us, yo. Now it's all coming to bear. And it just seemed like we left everybody behind. And no matter how simple we make it, we be over their heads, yo. We don't trust the white man. We don't trust. Come on, yo. Yeah, it's funny, yo. The evolution part is essential, yo. Everything around us evolves. You're gonna have medicine, it's got to be evolutionary minded. You know what I'm saying? Penicillin wasn't made with evolution in mind, yo. That's why these viruses and bacteria evolve, and they get what's it called, Shawn? Resistance. It's
Yeah.
called resistance. Yeah, it's the reason why these bacteria have resistance, because it has evolved. It was mutated. That's the real reason. So everything does that. Like you said, the new variant. It's a mutation. So it's not 20 coronaviruses, no matter what a nigga say.
Nah, he said something else. He says, I thought he said 300 or something.
Yeah, something crazy. If it was 200, he was wrong with 200. What you talking about?
Yeah, he was, either way, he was wrong.
Yeah, he was wrong, yo. And so people like that should go to school and challenge your professor after looking into the electron microscope. Yeah, don't talk to me. Yeah, so what's the word I want to use here? Hold on. Amino acids, proteins, how they evolve. Let me see something here. Wait a minute. I'll tell you what they call it. 1 second. I'm talking about it in the text. Damn it, can't find it, yo. How long you been rocking today, yo?
Not too long.
What was you basically talking about today?
Today I got into talking about quack medicine, the history of quack.
Did you put you got to put Dr. Saban in there, yo? Because
Nah, I didn't. I didn't put him in.
Do me a favor. Do me a favor, yo.
What's up?
Pull up the whatchamacallit article.
The Wikipedia
Yeah.
on Dr. Saban?
No, just pull up quack medicine, quackery, quack. Pull up quack.
And you mean quackery?
Yep, on Wikipedia. Yeah, it's called the astrobiology. Is a field in which, yeah, astrobiology.
There you go.
Y'all look that up. You pulled it up, yeah?
Yeah, it's on the screen.
All right, let's see. Hold on, damn it. All right, now go to major quacks. Let's see. Got a list of the quacks, right?
Yeah, you said go to where?
Right there, let me see. It's going to give you a name of infamous quacks.
Yeah, medical procedure fraudulent professionally.
Go
Qualified
over there.
charlatan.
In the context.
Snake oil over here.
Yeah,
Quackery.
Chris said.
History of European, United States, contemporary. Deceased living, prison, quackery. Persons accused of quackery.
It say what?
Persons accused of quackery.
Yeah, I think that's it. No, I don't got a list of them. Got a list of niggas?
Yeah, Thomas Allison.
Keep going.
What's the dude again?
You gonna see it?
He ain't got him in here.
Yeah, dude.
How's it?
Flip. Bowman, something Bowman. All right, tell you what, go back, flip back. Flip back. Now go up to the word charlatan.
He gonna be under there, man.
Yeah, hit that. Read what a charlatan is.
Emphasis. All right, a charlatan is a person practicing quackery or some similar confident trick in order to obtain money, fame, or other advantages via sort of pretense and deception.
All right, so okay, so now where's the list of infamous? What that list say? What you click?
Right
of what though? What's the name of the list?
Infamous individuals.
And go ahead, go to your homeboy.
He right here. He claimed to cure all diseases with herbs and unique vegan alkaline diet.
Right, and so he's a hero in this community, bro. So when you got a quack and the charlatan as a hero in your community, you're in trouble, yo. When you don't have like a real scientist or a real doctor is being the hero, you got a garbage community. There you go. Simple. It ain't even up for debate. It's not up for debate, yo. And we shouldn't debate them. We shouldn't argue with them. Because we see where they at. Yeah? Mm-hmm.
He'll quack.
Yeah. Charlatan. Of course, he never took no medical training. This ain't the 1800s where you just come up with anything and it was cool. Because ain't nobody know no better. We talk about the biome now. The human biome. You know what I'm saying? We talking about proteins and the average person to understand what a protein is if they just read. We look at the spike proteins on the coronavirus now. They take pictures of viruses, we can see them. Right? You talk about the ACE proteins, spikes. ACE2. Yeah, this is regular conversation for us, Shawn. So so when you start talking about Sadie, we just say quack. Charlatan. And they get mad at us based off the level of understanding, yo. Yeah.
Yep.
Yeah, you do. Yeah, you gotta keep it in there. Yeah, you keep it in.
Hey, so I was showing them on the screen outside of, when you were saying what you were saying, basically about the origin of viruses, but I wanted to skip toward where did they come from?
Where the quacks come from?
Nah, the virus.
Protein. All right, go ahead.
So it says, there's much debate among biologists about this question. Three main hypotheses have articulated. Now, I'm doing this because this is older information, okay? And then we can go up to more up-to-date information to be more exact. But three main hypotheses have been articulated. The progressive or escape hypothesis, it states that viruses arose from genetic elements that gain the ability to move between cells. Two, the regressive or reduction hypothesis asserts that viruses are remnants of cellular organisms. And three, The virus first hypothesis states that viruses predate or co-evolved with their current cellular host. So initially, this was like 2010 when they put this out. But there's something important that y'all need to pay attention to. In 2010, they were talking about retroviruses have a single-stranded RNA genome. So they were, 11 years ago, and even before that, paying attention to just how well these viruses had certain stranded genomes. So let me back off a little bit and let's go to, let's see if I can get him to give it to me. Thought I might have had an article already up on this. All right, nope, I don't want to use that one. That's the one I just had. So I can go to here. This was 2020. It talks about smallpox and other viruses plague humans much earlier than suspected, and it goes by that particular data. But it kind of confirms the history of viruses and how long they've been around based on this. What you mean, focus the screen again? What's wrong with the screen? Y'all want to see Sabi again being a quack?
He is though, yo. Oh man, yo.
Uncle, you were gonna go over there and debate chakras?
No. He was throwing our name around. You know how he do, yo. Throw our name around. But no,
Yeah.
he was the main proponent of chakras too, though. So now he just came up out of that and realized that everybody is crazy. Okay.
He logged in and even look at the article. All right.
So, no, I ain't debating no chakras. He got the right information on that.
Right now? That's what he debating.
I don't know who he debating. Oh, but he got the information on it. It come from the Indian text. Of course it do. Of course they're not real. Yo. We've been saying that for 20 years, yo.
Yeah,
so he's just catching up, yo.
Because you call Dr. Savior quack.
You said what happened? What'd you say?
We lost some viewers because you called Dr. Savior quack.
Did we?
No, I just playing.
I'm about to say they shouldn't have been over on that motherfucking channel anyway with that silly shit. We science based.
Somebody throwing the video down. We got our first thumb down today.
I mean, so what we supposed to do though? Hold on, man. What we supposed to do? Are we supposed to just leave science when it comes to medicine?
I don't know, but I got some. Yeah, I got something for it though. Hold up, I gotta put this on the screen though. Usually when I do science with Shawn, I always give somebody a little piece of something that actually they can take with them. So
yeah, that's a serious screenshot you got right there, yo. You think that's serious? I like that.
Yeah. So
yeah, that's hard. Don't run off that shit that quick, nigga. That shit hard, yo.
Appreciate it.
Like
Hold
that.
on, I got you on the panel, so this might be intriguing for you. But everybody else in the chat are already familiar with this. All right, so this is the 2021 edition, y'all.
What's that?
What is a virus?
Okay.
Lecture 1.
Proteins, envelope proteins.
Continue. I have been working on viruses since 1976. I've been at Columbia Medical School campus. I've been there since 1982. I have a lab that does research on viruses. I've been teaching about viruses. I've been teaching this course now. This is the 11th year. And I've written a textbook and done a lot of other things. It's my goal to teach you virology, to teach as many people in the world as possible all about viruses. And before this pandemic, at the beginning of every virology course, I used to say, if you want to understand all about human disease, if you want to understand human health, you need to know about viruses. And that's why I teach this course. I actually do it voluntarily. I don't have to teach at all being at a medical school, but I want you to know about viruses. And Columbia didn't have a virology
Shawn.
course for many years.
Yeah.
So that's why I'm doing it.
Pause that. So there you go. You heard what that man say, right?
Yeah.
So if you want to know about human health and the diseases, all diseases, right? You have to know about virology. Viruses. Did he not just say that?
Yep, he says what he said.
So how do we have people in the community that don't understand viruses and think they're not real, but yet lead the way in our health?
Mm-hmm. They say they ain't real, yo.
Right. Hold on one second.
All right, play it again.
Doing this. It's voluntary. Nobody's forcing me to do it. But the fact is, I love viruses, even though they have caused enormous devastation in the past year. They're amazing. I'm fascinating with them, and I have devoted my entire career to them. And I want to pass along to you some of my passion for viruses and make you knowledgeable more than most people on the planet. There's a lot of misinformation, and I want to fix that one student at a time. So this is my course for you. We live and prosper in a cloud of viruses. Viruses infect every living thing on the planet. There is no life form that does not have some kind of a virus that infects it. In fact, most have many, many different viruses. Humans regularly eat and breathe billions of virus particles a day. You're breathing them right now. They're floating around in the air.
Freeze, yo.
Your food, as we'll see.
Freeze. That man said we're in the cloud of viruses, yo. We eat and breathe viruses, yo. So what's the conversation, dog? Like, you know, I've been knowing this for years, yo.
Mm-hmm.
You know what I'm saying? Like the whole vaccine conversation was based off me understanding viruses and what they're gonna do and how they can get you. And like you just need to know, like your genome, a portion of your genome is made up of viruses. Like I've been knowing that for like 15 years, dog. I'll never forget, I used a science magazine. This was about 15 years ago. And when I first learned about your genome, parts of your human genome evolved with viruses. Because really viruses was pushing, you know, organisms trying to escape damn viruses because the virus was killing shit. And so you had to figure out a way to evolve. You know what I'm saying? What would later on become human had to figure out a way to evolve to escape viruses. Huh. That's fire, yo. Where you got that class at, yo?
You said where I got this at?
That's fire. Send that to me. You gonna show the whole thing?
Nah, I'm gonna show a little bit more of it, but not too much of it. But yeah, this the virology stuff, man.
That's the fire, yo. That's what I be trying to tell them niggas. Y'all like, yo, is you serious?
Yeah.
If you don't leave me the fuck alone, nigga, and let us develop a vaccine. Yeah, yo, we gotta figure out a better approach to get these niggas, man. You was parachuting with me the other night, yo. You not supposed to dive out your Mach 50 scientific jet, yo. You dove out there with me, yo. You crazy, yo. We parachuted down to earth to fight the Palestinians over rocks and bottles, yo. Go ahead, though, yo. That's fire. Show that old man fire.
And we carry viral genomes as part of our genetic material. Every form on Earth has viral genomes as part of their genetic material. It is just remarkable.
Shawn, pause that, Shawn. Pause that. One good pause that. Yo, I ain't even see that slide and said it, didn't I, yo?
Yeah.
Yep. And he said, you see that picture right there of that virus? Was that a spike protein? What is that? Virus, right? Yeah, remember Polite used that picture when he was trying to at the evolutionary conference, didn't know what the hell he was doing. Remember that? Yeah, he used that. Yeah, that's a fire ass presentation right there, yo.
Yep.
Yeah, nigga fire, yo. He got them niggas on lock. Ain't no getting around that old man, yo.
Right
He'll
here.
beat you up. He'll beat you up.
Yeah, quick.
He was like, nope, nope, food don't work, nope, nope, it'll beat you up. Yeah, I'm gonna take this course. What? It's a course, right?
Yeah, he got the course, and
Yeah, I'm gonna take that course.
supposed to be teaching free. Now I sent you the link already about the COVID-19 course. That's for free on their website that I sent everybody. I sent it out where people can learn more about the COVID-19 virus.
I like the virus class. Yo, it's called the chain. And look, this old man, I like the way he teach. But let me say this. I think this is important right here before you keep playing it. Now, when you listen to the pseudo talks very fast. He uses a lot of big words, and they try to go over everybody's head. That's what the pseudo do. So a real scientist don't talk like that. Like we can clearly understand what this man is saying. You see how simple that is? You see how the doctor was when she came on the show? Very clear, very concise, simple to the point. The pseudo go over your head with the big words and try to find all the big words they can to talk that talk because we mistaken that for being intelligence when it's not. In science, that's not. That's not how you do it in science. You do it the way they do it. You talking language of science, right? You know, certain words, right?
Yeah.
But the way the pseudo over dramatize and say everything and all that nonsense divine and be doing, yo, that's not what it is. So you can always tell a pseudo from the way he talk. Like sometimes when you listen to this man talk, he might miss a word up, he might stumble over a word, slow it down, mess. He don't be perfect is my point, and he don't be over your head. This first two, 3 slides he just did, yo, everybody listening clearly understands what this man said. One, we're in a cloud of viruses. Two, our genome, part of our genome is viruses. I don't think he got to the point where they say the viruses, outnumber us, more than 10 to 30. How you say that? 10 to 30 power? How you say that, yo?
Yeah, that's basically what he's saying.
Yeah, that's how much it is. It's just overwhelming, yo. So we just in a world of viruses. We in a world, yo. We have evolved to survive in a world. I will tell y'all this. Yeah, simple as that. All right, go ahead. That's a hard class. I'm in the class, yo.
Really, in the end, we're talking about huge, unfathomable numbers of viruses on the planet Earth. The number of viruses is staggering. And this is an example. This is just in the world's waters. People have gone out and estimated the number of bacteriophage particles in the world waters. Bacteriophage, which is pictured here, is a virus that infects bacteria, as the name would indicate. Bacteria, archaea, everything is infected with viruses. In the world's waters, there are over 10 to the 30th bacteriophage particles. This is just remarkable. That number is too big for you to comprehend. I don't get it. I don't know what 10 to the 30th is, but we can put it in terms that make more sense. Next time you go in the ocean, you take a mouthful of water and spit it at someone, you're spitting millions of virus particles in coastal water, in surface water, out in the middle of the ocean, way down deep, everywhere you go, millions of virus particles per milliliter because there's a lot of life in the oceans. Now, a phage particle weighs about a femtogram, 10 to the minus 15 grams. And if you multiply that by 10 to the 30th, you find that the biomass on the planet of bacterial viruses alone exceeds that of elephants by 1,000-fold. I mean, these are things you cannot see. That's just remarkable. And if you put these phages head to tail, they would extend 100 million light years into space.
Oh, freeze that, yo.
Way outside
Freeze that, yo.
planet.
Yo, did you see that? Did he that man just said 100 million light years, yo?
Yeah.
Forget it. So how we got people in the community that don't understand that? Like it's funny to me, yo. Yeah, they just make me don't even want to argue with niggas, yo. Look, you don't got the electron microscope. How are you making your determinations? Show me your source, yo. Or take me to your leader, yo. You tripping. Yeah, that's interesting right there, yo. That's a good class right there, yo.
Yeah.
You be sneaking that shit, yo. You don't let nobody know you got it, yo. You ain't sent nobody no link, man. You sent it to me a long time ago. You ain't sent that link to me.
I did send it. I even told you I emailed him trying to get him to come on.
Oh, yeah. What are you gonna do? Can we get him on? We can get him on.
He hadn't responded to my email yet.
All right, we gotta send Dr. Miata at him. That's how we do it. With the Morgan State joint on it. You feel me?
Yeah.
Yeah,
right.
you know how we do it. You know how we get around. More
Here we
than one
go.
way to skin the cat.
Yeah.
Mm-hmm.
Formerly known, or the Pluto former planet, you know, it's just way out there. It's farther than the nearest galaxy, 100 million light years. That's a lot of viruses, and you can't see them. That's the amazing thing. And the extent to which different life forms are infected with viruses is remarkable. I'll give you some examples. Whales are commonly infected with small, naked RNA-containing viruses called caliciviruses. They may cause various diseases like rashes and blisters and even gastroenteritis. Some of these viruses can infect us as well. But here's the thing. Infected whales excrete in the feces. This is an enteric virus in whales. Over 10 to the 13th caliciviruses daily. One whale, 10 to the 13th daily. It's just remarkable how many, and many other animals are similarly infected. Perhaps one goal I have for this course is for you to understand that viruses are not just bad news. Of course, this year, everyone is going to think that's all viruses do is make people sick, because most people have not thought about viruses before. But in fact, the vast majority are benign, maybe even considered symbiotic. So if you look in the ocean, and this is another great statistic, more viruses in a liter of coastal seawater than there are people on Earth. That's how many viruses are in the oceans. If you look at these two pie charts here, the one on the left is looking at prokaryotes, protists, and viruses. Right? So protists are eukaryotes, and then virus particles by biomass alone. And prokaryotes vastly outmass the others. There's more mass of prokaryotes in the ocean than protists or viruses. But if you look at particle number or abundance, viruses make up 94% of all particles in the ocean among these three groups. They are in the oceans. You may be wondering, what are they doing? Are they just infecting bacteria, protists, and fish and mammals?
You work.
They are, but they're not making most of them sick, actually.
What do you say, Unc?
No, go ahead.
Okay.
They are catalysts for biogeochemical cycling. They turn over carbon and sulfur and phosphorus. Without viruses releasing organic matter, the Earth would be quite a bad place to live. And we're just beginning to understand this. So they have huge roles in cycles on the Earth. Another interesting statistic today, there are 10 to the 6 genomes of HIV-1 on the planet, human immunodeficiency. We have another pandemic going on right now, and it's amazing most people don't realize that. It's the HIV/AIDS pandemic. There are 37 million people infected at the moment, and we'll have an entire lecture on HIV/AIDS to emphasize that. But we know how many genomes are in each person, and we can calculate 10 to the 16, also a huge number. And what does it mean? Well, among those genomes, because the viral genome is so variable, as most RNA genomes are, there already exists resistance to every antiviral drug we have. We have well over 30 antiviral drugs to treat HIV/AIDS that work very well. But there's already resistance to all of them out there. And no matter how many we make in the future, we will have resistance to them because of this genetic diversity. That's what that means, a number like that. What about us? How infected are we? Well, we at least have, and all of you have these viruses, about a dozen herpes viruses in us, like herpes simplex 1 and 2, varicella zoster, human cytomegalovirus, Epstein-Barr virus, and then human herpes virus 6, 7, and 8. You all get these in your first decade of life, and you have them for the rest of your life. There's no exception, and you can't get rid of them. Once infected, it's for life. I love to say, unlike love, herpes is forever.
Man, pause that, man.
Loving.
What
Can
that
I get
man just said? He said we all got herpes. Did he say that? Different types. The H, let me see, the herpes simplex. Let me see. Wow. Yeah, I can't. Indeed.
Yeah, that's where we get cold sores and stuff like that from, where they pop up every now and then. Fever blisters and stuff. Those are forms of herpes.
I know, yo, but that ain't the one you crack jokes you don't want to get, right?
That ain't the
It's
one.
just location. It's really location,
We
right?
talking about the sexual herpes.
Yeah, it's just location, though. Really, the only difference is location. Am I correct? Like the ones on your lips, it's the ones on your genitals. It's just location. Go ahead. What's up, Nahisi?
On a daily basis.
What's going on? I'm at work.
Okay, all right.
I'm just tuning in and out. That's it.
All right, man. We over here with the calm shit, yo.
Huh?
We over here with the calm shit. We was cussing niggas out yesterday.
I'm gonna check that out while I was at work. I think I got the right one on YouTube channel, right?
Huh?
It's on YouTube's channel, right?
Yeah, man. I'm solar mine. Man, niggas is ignorant, yo. It's a waste of time, nigga. Them fools.
You do that about 10, 15 years ago.
No, yo. We been for 15 years, yo. Ain't that crazy?
Yeah, it's been about that long.
Yeah, been about that long, yo. Nigga ain't won a conversation yet. Give him a victory here, yo. Just win, nigga. Wow. Hey, Shawn, so that's the whole course you going through?
Nah, it's just this today's the first of this course.
Was
Today the
that
first
an hour for the first video?
Yeah, the first people. They always
Oh, yo, killing them with that simple shit, yo. Damn, he ain't got nothing else better to do than sit in his office, yo, and beat niggas up. Damn.
Yep. Here you go.
I get posting on my social media. Dr. So-and-so cured me of herpes. No, it's not possible. Not today. Maybe in the future we could do that.
You want to say something? Go ahead.
Dr. Sabi.
Come on.
Dr. Sabi, it's not possible. Can somebody call Dr. Sabi? Oh, my fault. He died already. Nature killed him. Thought he was going to live forever. You may say, why are you saying that? I'm saying it because he was a charlatan on that.
We'll play it again.
Play it again.
Love. Herpes is forever. Because many of these you get from loving. And I get an email on a daily basis. I get posting on my social media. Dr. So-and-so cured me of herpes. No, it's not possible. Not today. Maybe in the future we could do that. But these are with you for life. And we're going to have a lecture that explains that. However, we have more than just a dozen herpes viruses. As you know, we have a microbiome that is unique to each part of our body. We have microbes in our mouth, in our respiratory system, in our skin, in our intestines, and so forth that have just been characterized in the last 15 years and which are clearly beneficial for us. And if we disturb the populations, we have problems. And many diseases are being linked to the microbiome and the products that they make, the metabolic products that they make. But we also have a virome. And here on the left is a diagram of what we know of the human virome. Again, every tissue and organ system has its unique complement of viruses. And here they're coded whether they're DNA or RNA containing viruses in blue or green by pie charts. And your skin, your digestive tract, your blood, etc., even your nervous system has viruses. Just think of this. There are viruses in all parts of your body. Most of them are not making you sick. We think that most of them are actually beneficial. Now, in recent years, we've developed technologies that allow us to study the microbiome and the virome. Of course, sequencing is a big part of that, but here on the right is a movie, which I'm going to play for you. And this is a drone, and on the top of the drone is a big petri dish, a plastic petri dish. And this drone is being flown by scientists on a nearby boat. This is off the coast of Australia, and these are whales here. You can see the blow coming out of these whales, and they want to collect the breath of these whales and see what viruses are in it.
Sean.
They fly open.
Yeah, now no, yo, I took this. I did this before, yo. Yeah, I can tell you what they're gonna do. They actually getting they getting the spit from the daggone whales, yo. Yeah, that's why I know this guy from right here, yo. All right, I got you. Yeah, this is super slick right here, yo. Yeah.
Over the whale, there's a little mechanism that opens it. So let's play it. There you go. See, the lid came up, and then it came up, it caught the mist from the whale breath, closes, then they go back, they bring it back to land, and they can sequence and find out what viruses are in whale breath. You couldn't do that before. You can't catch a whale. As I sit still while I sample your anterior nares. It doesn't work. This is brilliant. A combination of sequencing, of course, what you need to do this, and also the drone technology. So we can access a lot of different kinds of wildlife that way. As I said earlier, our genome contains viral information integrated in it. So here's a pie chart of the human genome, 3.2 billion bases. Of course, it's been sequenced many times in many, many humans, and it's divided according to what we've found. And, it's just embarrassing how little is protein coding genes, 1.5%. The rest is non-coding and has various functions. And what I want to point out to you here, these LTR retrotransposons, some of these are in fact remnants of viral infections, retrovirus infections, whose feature of their reproductive cycle is to integrate their nucleic acid into our genome. And these other signs, short interspersed nuclear elements and long interspersed nuclear elements, are also retro elements that can move around the genome. And these are beneficial. They can also harm us. But we have taken some of these viral genes and used them in the course of our evolution. And we'll talk about that in this course. In fact, the placenta would not be here if we didn't have a retrovirus that delivered the syncytin gene that's needed for the formation of the placenta. Of course, most people are interested in viruses because they cause disease. So here's a chart showing you the causes of 2017 global deaths. This is the most recent data I can find, and by different causes here. And you can see, of course, cardiovascular diseases are the biggest killer, cancers. And I've put arrows next to the viral diseases, of course. Lower respiratory infections, you can see diarrheal diseases have a lot of viral causes. And then where does COVID-19 fit? Well, so we have about 1.9 million deaths so far as of January 4th. And that would put it, just between digestive and neonatal disorders. That's a pandemic that's been going for about a year. It's quite remarkable. We'll certainly have far more than that by the time this is over. HIV, AIDS, hepatitis, many hepatitis infections are caused by infections. So we try to avert some of this, of course, by studying viruses and learning how to prevent or resolve infections. So let's take a look now at the current numbers. I'm going to switch to a live version of this. So when I started teaching this course, the Johns Hopkins site, which all of you certainly know, didn't exist. And I have some screen caps where the global cases, now 90 million plus global cases. This was 5,000, 10,000, 30,000. And I remember most of the red dots were in China, for many, many weeks and nowhere else. And then they slowly started spreading. So this is a wonderful website where you can go to learn the numbers, the cases, the global deaths. You can drill down by country, as you can see. And of course, we're leading in cases and in deaths because we have had a really poor response to the pandemic. We'll talk more about that later. Anyway, that's a great site. There's also a wonderful site in the New York Times where they show you cases in the US from March until the present. And they also have a map of the country where they, the red, the redder areas, the darker areas have more cases. And then they also have a world view, so we don't get too US centric, latest maps and data. That's the world view. And they have a map of the world with the heat map of cases as well. So lots of great resources to study this. Well, this is not a course about the pandemic, but you're going to learn virology and you're going to understand what's going on in the pandemic. The vast majority of viruses that infect us, as opposed to this one SARS-CoV-2 that's been killing so many people, most of the others have no impact on our health or well-being. And why is that? Why is that? Someone asked in the chat, why is it that people can have symptoms associated with herpes if we all had it? So that's an interesting characteristic of that infection because it goes into latent phases where it's silent and then it reactivates periodically and then you may or may not have disease. We'll have an entire lecture on that in this course. Well, many viruses just pass through us. You eat them, for example, in your food. And here's two interesting studies. In one, they looked at cabbage from 5 different supermarkets in Washington, D.C. And, cabbage is used to make coleslaw, of course. And each serving would have up to 10 to the 8th particles of a virus that infects the cabbage looper. This is a cabbage looper right here on the right, caterpillar of cabbage. So these caterpillars are crawling over the cabbage and they're shedding viruses. You can't wash them off. You just can't get them off, and it doesn't matter because they pass right through you. They cannot infect your cells. And we'll study why in that course, why they cannot infect your cells. Here's another example. If you take human feces and you sequence the nucleic acid, most of the RNA virus sequences, 91% of the RNA in human feces is similar to plant viruses. So we eat a lot of plants. They have their own viruses. We have them in our feces. They just pass through. They don't infect us. You can have your fecal virome done now. You can send feces to a company and they'll sequence the virome. And I routinely get emails from people, I have this plant virus. Is it bad? Is it a problem? No, it's not a problem. They're just going to pass through you. The most abundant human fecal virus is pepper mild mottle virus. It's a virus of peppers. Makes peppers look bad. And it's a long, flexuous virus, as you can see here. But it's completely harmless to us. 10 to the 9th virus particles per gram of feces, but they don't infect us. So most viruses just pass through us, and that's just the GI tract, but same for the respiratory tract, your skin. We are regularly encountering viruses that simply cannot infect us. As I said earlier, I think many viruses are in fact beneficial. Not all of them just pass through us. Many of them reproduce in us, but they don't cause disease. And I suspect that some of them are beneficial. It's hard to study that, though. We can't do the experiments in people that we need to know to do that. But here are 2 examples of beneficial viruses in systems that you can study. On the left is a plant called Dicanthelium lanuginosum. Sounds like a Harry Potter curse, right? This is a plant that grows at high temperatures. If you go to Yellowstone National Park with all the hot springs, these grasses will grow right next to them. 55 degrees Celsius, no problem. And they're able to grow because they have inside them a fungus with a virus in the fungus. Because if you take the virus out of the fungus, the plant will not grow at high temperature. And so you need both, the virus and the fungus for growing at high temperature. So the fungus has a place to live. The virus gets to grow in the fungus, and the grass grows at high temperatures. That's an example of beneficial viruses. But we can manipulate this in the lab and find out, and we can't manipulate people to take out their viruses and see what happens. Here on the right is another amazing one. There are lots of examples of this, but this is a wasp, a parasitoid wasp that lays its eggs inside of an insect larva, like a caterpillar. And the eggs then will hatch into baby wasps who then eat their way out of the larva. And what was that movie? Aliens, right? They didn't invent anything. It was already in nature. The wasp genome has encoded in it viral genes to make virus particles. And so when the wasp delivers an egg into the caterpillar, it also delivers virus particles. These blue dots here, it's a polydnavirus. It's a big DNA virus. And the virus delivers genes whose gene products immunosuppress the caterpillar so it won't reject the wasp egg. So this virus is good for the wasp, of course, not so good for the caterpillar, because it allows the wasp eggs to hatch and eventually not be rejected. There are all kinds of examples of this, of how viruses manipulate different hosts to benefit one or the other. Now, there is some evidence in mammals that viruses are beneficial. For example, this is an example of mice whose enteric tracts develop properly because of a norovirus. A norovirus is related to those viruses of whales that I told you about earlier. So it turns out these are sections of the intestinal tract of mice. You can see the villi, right? If you grow mice in a germ-free facility, that is without bacteria, their intestinal tract is aberrant. So the villi are morphologically aberrant, and the conventional mice are here. This is the controlled mice that have the normal complement of bacteria. So they're morphologically aberrant, and their immune system isn't properly developed. Here on the bottom, we're staining for CD3 cells, which are lymphocytes. And you can see the normal mice have the brown staining cells. Those are the immune cells, and the germ-free mice don't. So there's a defect in the morphology of the gut and in the number of immune cells if you grow mice without bacteria. You can infect these mice with a murine norovirus and partially restore all of this. So here you have now lymphocytes returning to the villi, and the morphology is a little better. It's not completely normal, but it's just one virus. If you infect these mice, and this is a murine virus, it partially restores the functions that are lost when you take away the bacteria. I just think this is amazing. Now, what about in people? We don't have any data because we haven't been able to study. We can't take away viruses in a similar way, although one day when we have broadly acting antivirals, we may be able to find out. The other reason why many viruses don't hurt us is we have an amazing immune system. So all those herpes viruses that are in you, they're kept in check most of the time by your immune system. Many other viruses that infect us are also controlled by this immune system, which we'll explore very briefly in this course, 2 lectures or so. But we'll explore the interactions of this system with viruses. And to emphasize how amazing this immune system is, when your immune system is down, if you're immunosuppressed, for example, if you are on drugs to take care of a cancer, they can immunosuppress you. Many virus infections can immunosuppress you, HIV/AIDS, measles virus, and others. And then you have problems. And if you take immunosuppressive therapy, for example, for various diseases, all these viruses that are in us can be a problem. And so liver transplants, when you get a liver, you get immunosuppressive drugs, and then human cytomegalovirus begins to reproduce and cause problems. You have it in you, we all do, and normally it's kept in check. But if you're immunosuppressed, then the viruses can cause pathology. So viruses not only pass through us, they reproduce in us, they're kept in check by our immune system. And there are many that reproduce in us but don't make us sick. And we'll explore some of these later. Here's a polyomavirus, a small DNA-containing viruses that infect everyone. Over 90% of the planet is seropositive. And there's slightly different kinds of polyomaviruses. You get these in your family. They're spread within your family. And so as your first 10 years of life, you get it from your parents and siblings. And we can trace population movements by what kinds of polyomaviruses they have been infected with. So here's a map of a human population movement. The dotted purple line is reconstructed by genetic analysis of populations, human populations. So humans moving out of Africa into Europe and Asia and eventually into the Americas, right? The black line is reconstructing human movements based on polyomavirus infections, much more granular, as you can see. You can even see moving into Australia. These are viruses that don't hurt you, again, unless you're immunosuppressed. Now, in a bigger picture, viruses clearly shape host populations and vice versa. So when a virus is introduced into a population, as you have seen last year with SARS-CoV-2, it kills a lot of people, can shape the population. And similarly, if a virus doesn't have a host, if the host is gone, if the host becomes extinct, there's no more of that virus. So it's a two-way street. And here's an example, which I love because this is a example of a virus that infects these eukaryotic phytoplankton that bloom in the ocean. You can see them from space. This is a satellite photograph of one of these blooms. The organism is Emiliana huxleyi. And these blooms get big, and then viruses infect them, and then the blooms go away. The blooms are collapsed. So that's an example of how a virus can affect a population. There are many, many examples, and we'll explore some of those later on in evolution. So in short, viruses are amazing. You've just never seen anything like it. You're going to love this course. You're going to love what you learn. You're going to be amazed. But what I want to leave you with just before we go into some detail is that virology is an integrative science. What do I mean by that? You need to know everything to understand viruses. There's no subject just of virology. Virology, to understand viruses, you have to know cell biology, biochemistry, physiology, even ecology, even sociology to see how populations interact, epidemiology, and many more. So that's what I mean by integrative. It brings together all these different disciplines. And I've had many students tell me, I took biology as a freshman, most of it didn't make sense, but in the context of viruses, now it all makes sense. That's the beauty of virology, because you need to understand all about how cells work to understand virology. And my goals for this course are shown here. I want to teach you the big picture.
All right, so I'm going to pause it right here. I want to kind of slide it through. I don't want to drag it out and go any further than where I need to go. Because he advertising that. But of course, he always give us a question, right? So which statement is true? All viruses make us sick and can be lethal. Our immune system can manage most viral infections. Humans are usually infected with one virus at a time. The press is usually correct in their virology reporting. Our immune system cannot handle most viral infections. So which one of these is true? Keisha said 2. Dave B said 2. Who will? Man, all right. We need a 15. Two. Science said 2. Pure say 2. DC say 2. We need like 8 more answers. Kesu says 1. All viruses make us sick and can be lethal. You sure about that? Remember what he said earlier about about viruses. when he showed the coleslaw and the bell pepper. When he showed the coleslaw and bell pepper, that was, you know. So again, which statement is true? All viruses make us sick and can be lethal. That's 1. 2, our immune system can manage most viral infections. 3, humans are usually infected with one virus at a time. 4, the press is usually correct in their virology reporting. 5, our immune system cannot handle most viral infections. It's got to be one of them. It can't be one or the other. There's a lot of no answers. Come on, what up, bro? He said 2. No, you ain't said nothing. Most of y'all must be cooking, driving, or something tuned in. Give me an answer. 1, 2, 3, 4, 5. Put a 1, 2, 3, 4, or 5 in the chat. About time you answer. 1, 2, 3, 4, 5, 6, 7, 8. 8 twos, 1 or 2. We need some more answers. Put a if you're listening in and you tuned in right now, just answer 1, 2, 3, 4, or 5. Or just put a question mark if you don't know. Aronde ain't answered the question yet though. Aronde answered the question. You laughing at pure, you ain't answered the question. And Zinga said 2. Come on, y'all. I'm gonna read it one more time. Yeah, like 2 more minutes. Which statement is true? All viruses make us sick and can be lethal. That's 1. 2, our immune system can manage most viral infections. 3, humans are usually infected with one virus at a time. 4, the press is usually correct in their virology reporting. 5, our immune system cannot handle most viral infections. Oh, yeah, okay, I see it. All right, I had to go back. 6, 7, 8, 9, 10. Ronald tripping. He said long. I seen it now. I seen it now. So again, I just seen a couple of more people just jump on, so it's a little late, but this is pretty much like a little quiz. We're having a little fun with it. So which statement is true? Number 1, all viruses make us sick and can be lethal. Number 2, our immune system can manage most viral infections. Number 3, humans are usually infected with one virus at a time. Number 4, the press is usually correct in their virology reporting. Number 5, our immune system cannot handle most viral infections. We need some more answers though. We ain't got a majority yet. We need like 5 more answers. Can we get 5 more people? Where is Chavez at? He ain't said nothing. Where is Tete? They're over there watching the chakra debate. Where Jamal at? Jamal, you watching the chakras too? Nah, I know everybody's saying 2, but the amount of people viewing the stream is where I'm getting the majority from. Water or Lafayette, none of above, because you can't know if your immune system can handle most viral infections, and you don't know which ones can be lethal. Water Alafia, that's not a correct statement. The reason why it's not a correct statement is because Kisu said one the first time, and that's not true. Because there's foods that we eat that actually have viruses on them. Nah, man, I ain't gonna say she made it up and she just don't know. She just taking a stab at it. I ain't gonna say that. Maybe she don't know. That's why we here to learn, you know what I'm saying? So I ain't gonna say that. But yeah, it's, there's viruses in your body right now that you're unaware of. And your immune system is functioning just fine. It functions just fine by the viruses that don't affect you. But when you come into a more lethal virus, like you said, the ones that are lethal, then that's when, you know what I'm saying, those are bigger issues. Now, the smaller viruses or the things that our body have naturally grown immunity to, and, the vaccines that we took as children help us defeat a lot of those lethal viruses that have plagued people in over human history. But like the novel viruses issue. That's correct. Yeah, you go do a different environment. That's absolutely. You go to a different environment. Like if all of us packed up and go to Africa right now, we're going to have to take a vaccine or pills because we're not going to be. Our immune systems are not, we haven't adapted to that. Now, if we're over there for a long period of time and we continue to stay there and we do adapt to going over there and being over there, then naturally we'll gain immunity to some of the stuff, but there's some things that we won't gain immunity to. Okay, let's get the answer. Appreciate everybody responding.
Do these quizzes throughout the lectures so that you get a break from listening to me and I can see if I've been teaching you. So what you have to do is go to this website and it will ask you for a room number, and the room number is virus, of course. And go there now and take this quiz. Which statement is true? All viruses make us sick and can be lethal. Our immune system can manage most infections. Humans are usually infected with one virus at a time. The press is usually correct in their virology reporting. Our immune system cannot handle most viral infections. Looks like most people got selected B, which is our immune system can handle most infections. That's correct. All viruses make us sick and lethal is incorrect. We are infected with one virus at a time, of course, is not correct. The press is usually not correct. Well, that's probably harsh, but you can see why that would be false. And our immune system can handle most virus infections. What is a virus? That's the name of this lecture, so let's define it. Here's my definition, which has changed over the years. An infectious obligate intracellular parasite comprising genetic material, and that can be DNA or RNA, often surrounded by a protein coat and sometimes a membrane. So let's break it down. And infectious, that's clear. Infectious means it can go from cell to cell or host to host. Obligate intracellular parasite. So obligate intracellular means the virus has to get into a cell in order to reproduce. If it doesn't get in a cell, that's the end of that virus. Needs to get inside. And parasite, of course, means one organism taking something from another. So viruses can take your life, or they can take materials that they need in order to reproduce. It can be very subtle or it can be very dramatic. Genetic material, DNA or RNA. Viruses are unusual because some viruses have RNA, and there's nothing else on the planet that has RNA as its genetic material. We have DNA, everybody else has DNA. There are some viruses that have RNA like SARS-CoV-2, and of course, that is because probably the first life molecules that evolved on Earth were RNA molecules, and the first life forms were RNA based. So RNA viruses are relics of what we call an RNA world. We'll talk more about that later.
I got a question for everybody in the chat listening right now. How many? Okay, let me make sure that I can say this to where y'all understand it. By looking at all these different virus types on this page, where is the coronavirus image at? Do you see the coronavirus image posted? If so, you can say in which direction it is, or try to explain it to me as clearly as possible as you can. Don't just say you recognize it. Give me a descriptive area of where it could be. I'll give y'all some time because I know there's a delay. It's just anybody who want to answer it. Let's see if we can get at least 4 or 5 or 6 answers. Nahisi, are you saying this right here, or this right here, or this one worm looking one right there, top right? Somebody said bottom left. Are you saying this, or this? Bottom of the screen next to the rectangular square with the hourglass shape. I said based on all the virus images on the screen, which virus image is the COVID-19 virus? Somebody said this one. Somebody said this one. Somebody threw a monkey wrench in the game and said somewhere up here at the top right. Somebody said bottom middle. I think the bottom left. Somebody said bottom center. Bottom center. The last option. Above parasite. Okay, so you saying this one's the SARS-CoV? Okay. Some people saying this one's the SARS-CoV, and some people saying this one the SARS-CoV. They look similar, don't they? They look similar. Watch this. Can y'all see that? Let's see if I can give you a better look at it. Now these are a little bit better, you know what I'm saying? These are a little bit better, right? All right, so look. Now, I just gave y'all a better opportunity. Ronald, you did a presentation. Where the presentation at, dog? So Even though they already answered this question, he asked it verbally. He asked what virus is alive, and I already showed the answer. So there's something else that I wanted to show real quick. I think this is on that besocreative.com where they're answering questions and things of that nature. And he asked, which of the following is a true concern, is true concerning bacterial versus viral replication? And it says, viruses must assemble using preformed components. Bacteria do not replicate via binary fusion as viruses do. Y'all should know this answer. Bacteria must assemble using preformed components. Viruses do not have an eclipse period. Or E, viruses replicate by binary fusion. Which one? A, B, C, D, E? Yeah, put it in my Facebook. Why you saying that? That ain't my arrow. Nunu said B. Okay, so I'm gonna read it again. It says, which of the following is true concerning bacterial versus viral replication? A, viruses must assemble using preformed components. B, bacteria do not replicate via binary fission as viruses do. C, bacteria must assemble using preformed components. D, viruses do not have an eclipse period. Or E, viruses replicate binary fusion. So what y'all got? Which of the following is true concerning bacterial versus viral replications? A, viruses must assemble using preformed components. B, bacteria do not replicate via binary fission as viruses do. C, bacteria must assemble using preformed components. D, viruses do not have an eclipse period. E, viruses replicate by binary fission.
Last one, Nick.
Unc says E. Nusha said B. I know they still waiting on the answer. Bella said he can't see. I'm gonna say it again.
I ain't see it. Where they get that? What was the answer? And that course you played?
I ain't telling you. Nope. Which of the following is true concerning bacteria versus viral replication? Is it viruses? Is it A, viruses must assemble using preformed components? B, bacteria do not replicate via binary fission as viruses do. C, bacteria must assemble using preformed components. D, viruses do not have an eclipse period. E, viruses replicate by binary fission. Chris says E. Lucia says E. Zinga
He was saying, what
they said E in the chat.
You're a smart guy.
All right, let's see what the answer is.
Fission as viruses do. Bacteria must assemble using preformed components. Viruses do not have an eclipse period. Viruses replicate by binary fission. Someone asks in the chat, why did it take longer to find huge viruses? One would think smaller ones would be harder to find. You know, it's a good question. They were only discovered 15 years ago. All of them infect amoeba, and nobody was looking for amoebal viruses. And I have to say that first Mimi virus was first seen in a specimen, and they thought it was a bacteria. So they put it in the freezer and forgot it for 10 years because it was too big. People weren't thinking about such big viruses. And now we show the results. There we go. That's what I was looking for before. Yeah, they were.
Look at y'all. Look at y'all. Nobody said, hey, I'm over here like, y'all answered this before. The last time he asked this question before when we did the quiz, and y'all got it right. I guess because I didn't play the earlier part of the video to jog y'all memory when he got to talking about this stuff, and that's why I tried to skip over it because he had mentioned this in the old bar. Yes, you should be very ashamed. Y'all answered it. How y'all get it right the last time we did it, and then this one y'all totally forgot. Some of y'all were thinking about that binary fission too much. I know you came in too late. She talking about she was about to say A. You was about to say nothing. I was about to say A because bacteria commonly reproduce asexual by a process known as binary fission. She didn't Google it, y'all. Don't call coronavirus. All right, so the answer is A. Viruses must assemble using preformed components. Let's see if he asks another question. Here you go, another question. All right, so which is a key concept first discovered about viruses that distinguish them from other microorganisms? A, they were too large to pass through 0.2 micron filter. B, they could replicate only in broth. C, they made tobacco plants sick. D, they were small enough to pass through a 0.2 micron filter. E, none of the above. So I'm going to ask again, which is a key concept first discovered about viruses that distinguish them from other microorganisms? A, they were too large to pass through a 0.2 micron filter. B, they could replicate only in broth. C, they made tobacco plants sick. D, they were small enough to pass through a 0.2 micron filter. E, none of the above. Ronald was quick on it. He said E. He's talking about I'm hate. Ron said E. Keisha said D. Zane said E. Dave B said E. Ron said, I don't know, to be honest. All right. Pure said beats me. Didn't Google D. Come on, y'all. We having a little fun, y'all. We learn. We having a little fun. Ain't no shame in that game. Come on now.
Sir, replicate only in broth. They made tobacco plants sick. They were small enough to pass through 0.2 micron filter or none of the above. So most of you got D. They were small enough to pass through a 0.2 micron filter. That was.
All right. So look, she said, I can't really start over. Nah, you shouldn't be trying to multitask while you're in class. Keisha Google, yo. I ain't gonna lie to y'all. She Googled. She cheated. She cheated. I can tell y'all that right now based on how she was just acting. So it's D. They were small enough to pass through. They were small enough to pass through. So, I mean, it ain't no more at this point. There are no more questions at this point. But you know, I'm gonna drop this in the chat for people. And man, watch this. This year's version of, you know, what is a virus. And it's important that we know what a virus is. It's important to know what a virus is. So you want to make sure that you gain some understanding right there and kind of deal with it. Let me see if I can close that out. Close that out. And let me see if I can go ahead and show y'all what's what. I need to send this to Unc too. Talking about his phone charge. He finna listen. You late. We done did our 3 questions. Okay, so Mondays and Wednesdays, the sessions are on Mondays and Wednesdays. Okay, this is the old stuff. All right, he just updated the information. Okay. And he got the slides all right here. Okay. So let me make sure I get this to Unc. Since he claimed he wanna be on board. Get it to him like that. Remember, y'all, let me share my screen. Share my screen. So he recommended this textbook right here. Principles of Virology, Volume 1, Molecular Biology, Volume 2, Pathogenesis and Control. You can get the PDFs for the slides here, Word document for study questions there, and you can deal with the actual reading from Chapter 1 and going to where they want to go to. Chapter 2 here, and we can deal with everything there going from there. So we can deal with what we want to deal with. A virology lesson. I gave y'all that homework. I'm gonna leave it right there. But man, what y'all got going on, man? How was today's information, man? Was it worth sharing, worth learning about? I mean, what was the deal with that? What y'all got to say about that? Every time about he was in the, you know what I'm saying? Listen, bro, stop making excuses. Mm-hmm. Let me send this over to Unc. Unc don't like it when you got some more information than him though, y'all. No, I'm just playing. But what y'all think about all of that, man? I appreciate everybody participating in the question and answer period because that's how we all learn, man. Yep, that's facts. Bro, that's facts. Yep. It'll be more. It's always more information coming. So we just got to be abreast of what's actually taking place, transpiring in the community, and then we just need to stay on top of what we need to stay on top of. You know what I'm saying? So that give us the one up. Like we can deal with what we need to deal with, and we can learn. And we can learn that way. So that give us an opportunity to just study and know more. Yep. Appreciate that. Don't forget to send me that presentation. I'm gonna look at it. I got the hold on. I'm gonna ask y'all one more question. One more question. Hold on. Your boy got Henrietta Lacks in here too, yo. One more question. Let's see if y'all get this right. I shouldn't have to say nothing or anything like that. Y'all should immediately know the answer to this question. A blank and blank cell is the only cell that can take up a virus particle and replicate it. Fill in the blanks. A, naive and restrained. B, primary and permissive. C, susceptible and permissive. D, susceptible and naive. E, continuous and immortal. Which one? Which one? Y'all done answered this question before, so that's why I'm saying what I'm saying. Nunu says C. What y'all got? Miss P says C. Jay, what you got? Thank you, Water Lafayette, for tuning in. Keisha says C. All right, Pierce says C. No says C. I don't know what R3 is. All right. Let me check. Okay, I got it. Got it. That's who else answered. Zinga says C. Hey, no problem, Zinga. Hey, if you need that source again, just let me know. Yeah, Voss asleep or something. All right, now why y'all remember this answer, but y'all couldn't remember the last answer? Dave, you sure it's D? Kitsu, you typed the wrong letter. A blank and blank cell is the only cell that can take up a virus particle and replicate it. Fill in the blank. A naive and restraint cell. B, primary and permissive cell. C, susceptible and permissive cell. D, susceptible and naive cell. E, continuous and immortal cell. Oh. No, you was in the chat. Keisha, look at her. I got every question right. You are every question got her wrong. The answer to this one, Dave, is C. It's susceptible and permissive. Yeah, it's susceptible and permissive. So let me go back. There you go. Look. A susceptible cell has functional receptors for a given virus. The cell may or may not be able to support viral replication. A resistant cell has no receptor. It may or may not be competent to support viral reflection. A permissive cell has the capacity to replicate virus. It may or may not be susceptible. A susceptible and permissive cell is the only cell that can take up a virus particle and replicate it. A susceptible and permissive cell is the only cell that can take up a virus particle and replicate it. The answer is C. Yeah. Okay, one more for the home team. Cause I know if I end the show, y'all gonna be trying to say stuff about me. All right. So when doing a plaque essay, what is the purpose of adding a semi-solid agar overlay on the monolayer of infected cells? Now, people who ain't never said this don't know the answer. Look at her. Is it A, to stabilize progeny virus particles? B, to ensure the cells remain susceptible and permissive? C, to act as a pH indicator? D, to keep cells adherent to the plate during incubation? E, to restrict viral diffusion after lysis of infected cells? Ooh, look at them answers coming quick. Lulu said B. She ain't playing. What's the answer, y'all? I got two B's. I got an E, B. Nunu said she thinks she just jumped out the window with her ran. And Zynga said B. Ronald said he going with B. Just woke up. I missed 3 hours. Yeah. It went 3 hours because of Unc, but we on the back side of it right now. I didn't want to make it 3 hours. It was actually should have been about an hour. And then we got the talking, and then next thing you know, we got Unc on, and then next thing you know, I started playing the video. And then Unc started making me pause the video every 1 minute or every two words. What's the answer though? Cool. Rob Rand said he got his book. Pierce said he cheated off a newspaper. All right, so let's go back. When doing a plaque assay, what is the purpose of adding a semi-solid agar overlay on a monolayer or infected cell? They go to plaque assay right there. My bad. Oh, y'all wrong. We finna look up the answer. We finna look up the answer. There go the viruses right there. So formation of that, and then examples of cytoplasmic effect. And then here we go. How many viruses is in a sample? Infectivity, physical particles and their components. And then we have used to study. All right, shoot. I keep hitting my mouse to the left. You said it's the choice with the pH. Let's see. We're gonna have to read the fine words right here in this slide coming up. Right here. Research on the growth of characteristics and genetic properties of animal viruses is still greatly in need of improvement. Quantitative techniques such as those used in the related field of bacteriophage studies. The requirements for quantitative virus technique are as follows. The use of an uninformed type of host cell, an accurate assay technique, the isolation of the progeny of a single cell virus particle, and for the separate isolation of each of the virus particles produced by a single infected. It ain't that. To stabilize progeny in virus particles. The isolation of progeny of a single virus particle. That's your answer. A. Because it's not to ensure that the cells are that, and it's not to act as a pH indicator. It didn't say that. And to keep cells adherent to the plate during incubation. See? Production of plaques in monolayer tissue cultures by single particles of animal virus. And then it says the use of uninformed type of host cells. Well, the requirements of quantitative virus techniques are as follows. 1, the use of uniform type of host cells. 2, an accurate assay technique. 3, the isolation of progeny of a single virus particle. 4, separate isolation of each of the virus particles produced by a single infected cell. She said, okay, I missed one. We got some work to do, ladies and gentlemen. It's all right. We got some work to do. It's all good. This next week's stuff anyway. So in a particular to Pofu ratio particle can be described as, I know y'all ain't gonna know none of this. So we'll deal with it next week. But yeah, man, so appreciate everybody tuning in. Y'all know how we rock out, man. You know what I'm saying? I'm gonna say Shimon Hotep, and on that note,
was in. The books are in. Yep. They're in. They're here.